Hey, what's up? My name is John Hammond, and I want to thank you for checking out my PicoCTF tutorial videos. I think that CTF and Capture the Flag is one of the best ways to learn and practice your cybersecurity skills. So I hope you learn a lot, and please enjoy.
This is the first video in my attempt to record what I can of the PicoCTF 2018 game. I'm not going to go through the game rendition of this. I'm just going to be actually solving the CTF challenges through the problems page itself. So I'm running Linux, right? And I'm going to try and make this as beginner friendly as I can for the first segment or so, or for the first couple of videos in the series. So I'm still friendly to people that haven't been doing this for all too long. So let's go ahead and get started with the first couple of challenges. Running Linux, so I have a terminal open. I have a folder created for the game. I have a lot of the folders already created for the first couple of challenges that I want to solve in this video, and we'll keep creating folders as we move on. So let's just go ahead and get started. This first challenge here, Forensics Warmup 1. Can you just unzip this file for me and retrieve the flag? So if you wanted to, you could click on this and download it and move it into the folder or whatever. What I like to do, and I've been doing in a lot of recent videos, is just right-click on a link and then open or copy the link address so that I can, in my terminal, wget it, which is default on Ubuntu, or I think it's default in Ubuntu, whatever. Some Linux systems where we can just download that file. If you don't have it, you can sudo apt or sudo yum install, whatever package manager you're using. Hopefully you're running Linux. So that way it'll automatically get the file in our current directory where I'm working with in the terminal. So we have flag.zip. I do want to move this into Forensics Warmup 1. And I totally forgot the flag file. All right, so 1. There we go. Now I can go ahead and work with this thing. If you were to use just a file explorer, you could click on it and open it up, and that's cheesy and fun and cool, but I want to do this from the command line. I want to automate it, so I'm just going to unzip, which is again a built-in, I think, on Linux, where we can, if we have zip tools, we can go ahead and unzip it and unzip flag.zip, and it will create this new file folder for us, flag.jpg. So I'm going to eye of gnome or EOG that image, check it out here, and it says PicoCTF, welcome to forensics. I'm going to try and write that down. So I just use Terminator in this case to go ahead and split my screen. So I'm going to use PicoCTF is all lowercase except for CTFs. And it looks like all of this is lowercase. Welcome to forensics. Cool. So I use nano as a text editor there just to go ahead and save that. And let's paste that in, see if we get the points. Nope, I failed. I had an S in there. Welcome to forensics, not welcomes. I like to keep these videos in this series. Holy cow, I can't speak. I like to keep these videos pretty real, so hopefully you can bear with me. Hopefully it's fun, whatever. Let's go ahead and close out of that. I don't need Eye of Gnome open anymore. And once I move out of there, I can move Forensics Warmup 1 to complete. So now that that's marked complete, we can move on. All right. Forensics Warmup 2, for some reason I can't open this PNG. Let's go ahead and check it out. Move into Forensics Warmup 2, wget that file. And now we have it as a image file, just a PNG. If I click on it though, or open it up, it just won't open. It says fatal error reading PNG image, not a PNG file. So we could go ahead and run the file command on this file flag.png, and it reads it as instead a JPEG image. So what if we were to just simply rename this file to not flag.png, but flag.jpg? Now could I simply Eye of Gnome or open it in Nautilus as I had before? So let's just run Eye of Gnome flag.jpg. And it says PicoCTF extensions are a lie. Nice. Let's jot that down. Extensions are a lie. And if I wanted to, I can cat flag.text and pipe it to xclip. And if you don't have excuse me, I'm sorry. If you don't have xclip installed, you can sudo apt install xclip if you wanted to. And I actually just have it aliased to xclip selection clipboard, so whatever I pipe into will automatically be copied into my clipboard. Go ahead and paste that in. That's correct. Cool, we're moving on. Let's go ahead and move into general warm-up number 1. If I told you your grade was 0x41 in hexadecimal, what would it be in ASCII? You can check out the hints here, and there are usually hints for a lot of these tasks, which is pretty handy. It says, submit your answer in our competition's flag format. So, example, if your answer was hello, you would submit PicoCTF curly braces hello as the flag. So it just wraps around. let's go ahead and try that. Let's move into another folder for us after we mark this challenge as complete, the previous one. And our answer is 0x41 in hexadecimal. We want it in ASCII. So if you don't know what ASCII is, you could go ahead and Google that. There is such thing as an ASCII table, but ASCII is really just like, okay, the kind of procedure or character encoding standard for electronic communication. So numbers in the range from 0 to 255 have a kind of representation when you look at it as text. So if you wanted to, we could view it in a ASCII table, which I guess I'm just going to go for an image of. Standard character ASCII set. If we had 0x41, which is what we are looking at in hex right now, I'm going to fire up Python. So you can just see that in decimal is 65. So in our ASCII table, if you wanted to check out the hexadecimal column, the hex you can see in the middle there, you can check out 41, and that is 65 in decimal, as it sees in the same column. The CHR, or the character of it, when it's considered to be represented in ASCII, it's just a capital letter A. So that should be the flag. Let's actually just take note of that. Flag.text. PicoCTF, remember it wants it wrapped in there, PicoCTF-A. And if we wanted to, we could go ahead and actually create a getFlag script in Python. So I'm going to do this in nano again. Let's do nano getFlag.py, get a simple shebang line, which is necessary for the system to know what kind of script we're running. Let's go ahead and print out PicoCTF with curly braces, and then let's use %s to denote that I'm going to be using a format specifier here. I'm going to use the percent sign, and I want to take the string of 0x41 as we expected here. So 0x41 is going to be evaluated to in decimal, because Python represents everything typically in decimal, so it'll go 65 first. And actually, I'm sorry, we don't want the string of that. We want the character version of it, or it in ASCII. So it's not str we want. We're not going to convert just the number 65 to a string. We want it converted to ASCII. So let's use chr to get the ASCII value. Let's go ahead and run Python getFlag, and it's PicoCTF-A. So great, let's convert that to an executable, or not convert it to an executable, but mark it as executable with chmod. Then we can // it, and then if you wanted to, just for handy purposes, you could redirect it to flag.text, but we already have that done for us. So let's go ahead and submit this. Paste it in. We are correct. Cool. And I moved all of that into the big folder here. Let's put it all in general warmup. Cool. So let's check out, after we mark that one complete, we can check out general warmup number 2. What do we got here? Can you convert the number 27 to binary or base 2? Yeah, we can do that in Python a little bit more as well. Let's go ahead into general warmup 2, and let's go ahead and copy the general warmup 1 getFlag script into this directory. So we can go ahead and nano that, and then instead of actually converting this string of CHR 0x411 as we had in the other challenge, let's actually take the number 27, treat it as an integer, and in Python you can actually pass a second argument to this integer function, and you can say what base you want it in. So I'm going to say 02, but if we were to check this out in Python, comma 2, sorry, not 02, so base 2, if I were to check out what this gives me in Python, int should be converted as a string. Oh, I'm sorry. I'm totally going wrong here. We want to just run the function bin, because that'll convert it to binary for us, not into. Into will expect to take a string given a base and interpret it as a different number. So bin2 was really what we want here. Except when I run bin2, you'll notice it returns a string for me, but it uses 0b as a prefix to denote that, okay, this is binary numbers here. So we could actually go ahead and slice that. And slicing in Python just means kind of indexing, but cutting pieces off of it. So if I want to take the second character and like the first 2 characters off, I could say, let's go 02, let's go 2 characters in, and then colon to cut from that position, 2 characters in, all the way to the end. So all we have are the 11011. It just slices that end bit off for us, just like that. So I'm totally wrong. I'm sorry I kind of went down that rabbit hole with, you know, giving you the wrong information. You're trying to call the int function when you should run the binary function. Sweet, whatever. Let's go ahead and try and run that. Let's run Python get flag, and now we have PicoCTF 11011. Submit. That's correct. Awesome. Let's go ahead and redirect that to a flag.txt file, just for good practice. Move general warmup 2 to be complete. And let's check out get general warmup 3. I'm probably saying words that I don't even mean to say here. Whatever. You guys know how it is. What is this number, 0x3d base 16 hexadecimal, in decimal base 10? This again wants it in the flag format, so let's do the exact same thing. Let's change directory into general warmup 3, copy general warmup 2, all the way, their get flag script all the way into this directory, not too far on the file system. Nano get flag to change the script up, and let's go ahead and change the 0x3d from decimal into decimal base 10. So since Python will automatically want to convert this to decimal, it'll go ahead and do that, and then we can run str on it to get the number that we're expecting here. So let's run Python get flag. We get 61. Redirect that to flag.txt file, xclip it so we have it in our clipboard. Let's go ahead and paste it in, and we are moving, just like that. So cool, 250 points, just kind of breezing right through some of these. I hope you're learning a little bit. Just right now, this is simple stuff, right? These are just warm-up challenges, but they're still good to knock out of the way and showcase what you can do with Python. Python is certainly going to be your sword in a capture the flag or CTF game, so I don't know, don't take it lightly. Know how to do just about everything you want to do with it. In this video, I want to take a look at the resources challenge. It's only worth 50 points. It says, we put together a bunch of resources to help you out on their website. If you go there, you might even find a flag. And here's the link to the page, and it offers just a link that you can click on right here. This challenge is a little trivial. It's not too hard. Really, it's just look at this page and read through it. You've got some links here to check out: general skills, cryptography, web exploitation, forensics, binary exploitation, reversing, and a lot of other really cool stuff. Honestly, I haven't gone through this yet. We actually have a featured YouTube channel, so that's pretty neato. Totally, I want to take a look at that. Oh, it's Mr. Carlisle. He is fantastic. I know him kind of personally through some of my stuff at military academies. So there's a lot of really interesting content here that you can totally read through, and I would recommend it. And it's honestly just a good place to go to when you don't know the answer to one challenge or something that you may be looking at, kind of under that umbrella of the category, of the challenge that you're working on. And it's awesome when you're doing that in CTF. So this is certainly a good resource, and that's important to kind of have in our back pocket. At the very bottom below this video tutorials here, it says, thanks for reading the resources page. Here's the flag for your time, which you can copy and paste, take note of, and I'll actually do that. I'm going to create a flag.txt file, as I usually do, and we can go ahead and head back to the original page, submit it for our 50 points. We can put this together in a get flag script if we just copy the link address as we usually do. I'm going to use curl, which you may have seen or used before. If not, you can just sudo apt install curl if you don't have it installed on your system, or whatever package manager that you need. So curl will allow us to make a request to the web page and view the output of the page. So literally seeing the HTML source. You can see the flag right here in the output. So what I'm going to do now is go ahead and pipe that to grep, and a lot of times I've done this in previous videos, so hopefully it's nothing new. But if it's a new technique for you as you're starting to watch these videos for the first time, cool, hope you enjoy. Grep will let us search, at least when we're piping, at least through the output that we give into the program. And I'm using tac-o for only, so I want to return only the search results that I return and wanted to filter for to begin with, and tac-E to get regular expressions or extended regular expression support. So that way I can use the flag format, PicoCTF, and then the curly braces, and I'm going to use some regular expressions inside here to say period and then a star. So period to match anything, and then a star or asterisk to match multiple, or as much as you can of that. So once I run through that, it says a little bit of the curl connection stuff, so I'm going to go ahead and make that silent with tac-S, and then I'm going to use tac color equals none on grep, so we don't get that red color, and that will return only the flag for us, so that's pretty handy. Okay, I'm going to go ahead and make a get flag script with that. So nano bin bash is a shebang line, pump that there, mark that as executable. It runs just fine, and we can mark that challenge as complete. All right, what do we got next? These are words. Reversing warm-up number 1, 50 points. Throughout your journey, you'll have to run many programs. Can you navigate to this on the shell server and run this program to retrieve the flag? So it allows us to download the program. Let's go ahead and do that. I'm going to make a directory for reversing warm-up number 1. Head to that directory, wget that file. And if you have not used Linux before, or you just don't particularly know how to run stuff, you will want to /, and that's kind of the term, I suppose, the colloquial name that I'm going to go ahead and use that I normally use, because you want to say in this current directory, so the period or the dot to mean the current directory, relative to it, I want to run this file, or whatever program we want to run. Except it has to be marked as an executable. So the way you can do that is the simple chmod command to like change or modify, make modifications to the file to add permissions to it. And plus X, that X or the executable bit will mark it as executable, and we just have to supply the file that we want there. So now if I run /run, actually if I were to check out ls, you can see it's highlighted green, and ls-tech-l, you can see I've added the executable bit to all of the columns here. So myself or the owner, the group that owns it, that's the third column. Again, it's still me and my group that owns it, and then everyone. So everyone can run this. Now /run, and we get the flag. So if we wanted to put that as get flag, or redirect that to a static file, and we can actually just move the program itself to named get flag. Simple stuff. Okay, let's go ahead and submit this flag. Easy. And as usual, mark this challenge as complete. Okay, next challenge, reversing warm-up number 2, is can you decode the following string from base64 format into ASCII? So base64 is super duper common in capture the flag competitions. If you haven't seen it before, you can simply Google it. Base64 on Wikipedia is a type of encoding or a scheme of representing characters and data and information in a peculiar way. It is pretty easy to identify because it'll look like a lot of seemingly random like letters and uppercase, lowercase letters with occasional numbers thrown in, and the only other characters aside from that are acceptable are a plus sign and a /. So those are the acceptable characters in the base64 format, and you'll see those just maybe rarely, but the most common stuff are seemingly random uppercase, lowercase letters, more uppercase than usual sometimes, and that's what makes it kind of easily identifiable. The most important telltale about base64 is that it ends the very, very end of the string or of the encoded data is normally a set of equal signs. It doesn't have to have a set of equal signs, because the reason that the equal signs are there is because the length of this data has to be a multiple of 4. So if the encoded information, like if the transformation of regular letters into their encoded form does not end up giving you a perfect factor of 4, like multiplicand, if that's a word, multiplicand, I don't know. If it's not a multiplication factor, or if it's not a multiple of 4, it will add these equal signs at the very, very end as padding to make sure that it will eventually, like you'll have 1, 2, 3, or none sets of equal signs there at the very, very end to make sure that it's a length of a multiple of 4. So peculiar thing. In this case, we don't have a equal sign at the very, very end. And okay, if we wanted to, you could just go to an online tool to base64 decode information. There are a lot of these that are crappy and stupid and dumb, and they waste a lot of time, in my opinion. I want to be able to automate this process. I want to be able to do it from the command line or from Python or whatever that we're working with. So there is a utility, base64, that you just have on your command line. And normally I would echo stuff into this. I would just pipe it in, and that will decode it for us just fine. Another tactic that I've kind of seen, which may be another interesting style, is if you read it in at the very, very end by using these 3 less than redirection signs. So just like that, and you'll still decode it as you would expect. Python can do this as well. You can just have a string, and you can do .decode base64, and that's the route that you should go. Another option is to import the entire base64 module and then run base64.b64 decode on it. But I want to get in the habit more of just simply using the string.decode base64 because you don't need to import a whole module. It just seems to be a little better, a little faster, whatever, nicer. So that is the flag. We can go ahead and actually make a specific directory for that. Reversing warmup 2. Actually, I'm going to mark this as complete already since we know that we've got the flag at this point. And we can go ahead and do just that. I'm going to use Python to actually print out the PicoCTF portion of it that I want, and then I'll get the %s in there, and I'll percent it with our string that we have decoded from base64. Okay, now we have a simple get flag script. Not particularly necessary in Python because I did it from the command line one, so I guess I don't know why I did that. I'm using bash to just call Python, but simple stuff. You could have done that in just Python if you wanted to and created a Python script just like that. I should have done that. Cool. Let's go ahead and run that. Redirect it to flag.text. Throw it in our clipboard so we can submit it for points. And keep winning. Cool. Hope you guys enjoyed this video. It's been fun. I think the first set of the PicoCTF challenges are for someone that does a little bit of CTF stuff, like that is used to this kind of material, this kind of content. This stuff is pretty easy to run through, and I'm trying to describe what I can. And if you haven't seen it before, and hopefully I'm not jumping into too difficult of concepts or being too quick on the keyboard for some interesting things. This first one, Crypto Warmup 1, 75 points. It says creepy toe, or a typo on crypto, that's funny, can often be done by hand. Here's a message you got from a friend, seemingly gibberish, with the key of this is a lil key. Can you use this table to solve it? So let's go ahead and just download this. And I'm actually going to do this I'm going to use curl for this. Let's make a directory for it. Creepy toe. Crypto Warmup 1. And I'm going to use curl to download this because it's nothing huge. It's just this bit of information. So this is the table that it suggests us to look at, right? And this essentially is trying to put together or illustrate the encryption and decryption of another message or a plain text message with a specific key. So letter by letter, you would look at one of the letters that, okay, let's say is in the original plain text message. I'm sorry, I'm blocking my mind trying to think about this. And you would use that as a row or a column. And then you would use the other first letter or the corresponding letter position in the key. And you'd use that as the other, maybe your column or row. And then because of this transition on the table, because it shifted, the alphabet is shifted kind of letter by letter in this case, as you kind of move either across one row or down one row, as you can see, that is what is going to end up giving you the letter of your, excuse me, the letter of your ciphertext. So the letter inside the grid here, or inside the table, is what you would expect to see as your ciphertext. So in our case, we're given something a little bit interesting. We're given this LL blah 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 with this is a little key as the key here. So I'm just going to paste this so we know what it is, and this is a lil key. And I'm going to try and illustrate this or explain this and how we would go ahead and decrypt it by hand, but I'm not going to have us decrypt it by hand because that's stupid and dumb. We're smarter than that, and we know that we can automate these things. So let's say we had the letter L, and that's our ciphertext, right? And we know that it is in the middle of the grid because it's our ciphertext. But we also know it's going to be in the T column of something, right? Because the key in the corresponding side is what we're using as one edge or the boundary and barrier of this table here. So let's find L in, let's say, a T column here. So I'm going to move down until I find L. There it is. And if I move all the way from that L to determine what it would be on the plaintext side, or what we've deemed to be the plaintext side, we would see S. So we know that S is going to be the first letter of our plaintext. Let's do the same thing for L, but now this H as what we're using from our key. So H, let's say the column here, look for, again, L. So, I'm sorry. We see that the following letter should be E. So C, SE. So whatever that could mean following, we could go through that procedure until we got it. However, I want to kind of enlighten you and teach you a little bit more about what we're actually looking at here. So this whole block, this whole diagram, this whole table that we see is the alphabet shifted over and over again in a peculiar way, right? It's just one character by character. So the real name of this is something that is associated with Vignir. And I'm saying that wrong. I don't know the correct pronunciation. But the Vignir, whatever, that cipher is a form of a polyalphabetic substitution cipher, and it uses a table, or the Vignir table, which is the Vignir square, which is exactly what we're looking at. That's that text, table.txt file that we just downloaded. So this is a Vignir cipher. We can actually, if we wanted to, do something online. Let's just get like a Vignir cipher decoder and just take a link here. That's perfectly fine. Let's say, okay, cool, it already knows what we're doing here because I tested this earlier. We have the ciphertext that we can paste in. We know the key, so we can paste that in, and then we can run decrypt Vignir, and it says secret message. That is the full decryption, or the full original plaintext given the ciphertext and key that we know. So I actually have another video on writing this or doing this in Python, and I think it's part of the TJ-CTF video series, and I do this often, right? The Vignir cipher is a kind of a common thing in capture the flag competitions, so you can totally find it. I certainly have videos on it. But right now, we know that our flag is PicoCTF, secret message, and I could write something to do a get flag script with running this, but I'm not going to track down that code. Actually, screw it. I'll track down that code. Let's see if I still have it. I may not, because I tried to clean my hard drive. Vignir square, Vignir cipher. Looks like I have it, or a copy of it. Oh, I have it in my original PicoCTF folder. So let's try that. Subbool Vignir cipher. Pull it up. And I have insert the message that I'm using, or really the ciphertext that I want to see. So I'm going to run decrypt on it. Encrypted, this is the little key. And what I'm doing is I'm taking the lowercase letters of the alphabet, and I don't know if I need digits in there. I can probably remove that, but I guess it's doing it just fine. And I loop through the key. If it's not the same size, I iterate it and cycle it if it's not the same size, because you will have to repeat the key until it's the length of the message that you originally see if your key is less than that. But since our key is 13 characters and our message is 13 characters, it's totally fine in this case. I remove punctuation because that's kind of the habit and the standard that you would do in Vignir cipher. And then I try to take the position that I see, or the cipher letter and the key letter that I'm finding their original index, and shifting or rotating the alphabet just as you would see on that Vignir square or the Vignir table, and then determining what the new character is based off of the index of the cipher. So I'm essentially automating what we did when we visually looked at it, and I put it all together. And decrypt, I just go the other way on that table. So I can run this, and we see secret message. So I'll save this as getFlag.py, and I will print out PicoCTF with the format specifier formatting decrypt in there, and that is our getFlag script. So mark that as executable, and we've already got that flag saved, so we're good. Let's mark that crypto warm-up challenge as complete, and I should probably copy the flag. Go ahead and submit it. Oh, it's not running because I changed the directory name. Stupid me. Submit. 75 points. Oh, it probably doesn't even need it. I think it's just... Oh. Let's check out what these hints say. Submit your answer in our competition's flag format. For example, if your answer was... Oh, please use all caps for the message. Odd. Let's change that up in our script. Let's actually do that for our getFlag script in here. Replace it, redirect it to flag.txt, xclip it, and submit that. There we go. That's much better. Sorry about that. Okay, properly spelled cryptography doesn't have to be complicated. Have you heard of something called ROT13? So if you don't know this, again, you can Google it. ROT13. It is a simple letter substitution that is essentially a Caesar cipher, right? If you haven't heard of a Caesar cipher, it is that shift of the alphabet, or just moving the letters. Rot 13 is moving the alphabet kind of in half, right? Because 26 letters, 13 of them, so you just move them over to the other side of the alphabet. You can read more a little bit about the page, but it's a common thing. Again, you have online tools if you want to work with them. You can paste them in and get the flag just like that. PicoCTF, this is crypto. If you want to do it from the command line and automate everything just like I do, you can go ahead and do that. Let's get the original prompt here. Make a directory for it. I'll mark it as complete again. Crypto warmup 2, nano, let's do getFlag.sh, bin bash, echo this, and pipe it to rot 13. So rot 13 is installed from BSD games, so sudo apt install BSD games, and you get Caesar, which allow you to actually control the shift, but rot 13 will only shift by 13 characters. So that's kind of an interesting thing, a peculiar thing, and a good tool to have in your command line toolkit. Already solved it. All right. Let's check out grep 1, because this is another simple challenge. You can find the flag in this file. We don't need it on the shell server. Let's just go ahead and download it. And we have used grep before in a previous video, so hopefully it won't be too hard to pick up or grab, just because I've tried to showcase it a little bit before. Make directory grep, and let's mark it as complete, just because we're confident and we know we're going to get it. Let's download this. And let's grep for PicoCTF. Let's do everything. Let's just get the flag format that we want out of the file, and just like that, easy. Let's get color equals none in there. You might have to do the same thing, because your ending hash or the hexadecimal stuff that's added at the end of your flag will be specific to your account, so don't use my flag. Paste that in. Kind of simple in this case, but knowing the flag format is what is important in this case. And grep to just quickly hunt and search for stuff is important, because if we were to actually check out the file, there's a lot of nonsense in here, right? And it's probably all on one line. So we would just regularly grep. You could just grep for, oh, let's look for PicoCTF in the file, and oh, I guess you'll find it anyway. It is on its own line. Peculiar, cool, but good to know. If you want to, yeah, it's on its own line. Wow. If you want to determine only what you are returning, just to use that tag lowercase o, and you'll get only, which is a good hint. So let's submit that. All right, netcat. Using netcat will be a will be a necessity throughout your adventure. I gotta stop this video. I'm gonna lose my tongue. Can you connect to this at this port to get the flag? I've covered netcat a lot, and it's super important in a lot of like CTF challenges and capture the flag competitions. So let's go ahead and make a directory for this challenge. Simply netcat. I probably could have marked that as complete, but netcat to a specific host. If you don't know what netcat is, it is a program that will allow you to connect to a remote host on a service, on a specific port. So some software or some script or some code that's running on that service, or kind of controlling that socket, is what you are connecting to and what you're going to interact with. So you netcat to a specific host at a specific port, and as you are connected, it says, hey, that wasn't so hard, and it gives us the flag. So super simple challenge. I'm going to use tail tac n, so I get the very last line, and that is going to be our get flag script. Shebang line as usual. Pump our line in there. Mark it as executable, flag.text, xclip it, and we can paste that in. So, cool. Hopefully that one is another simple and easy. Wanted to showcase a little bit of the cryptography stuff and showcase simple grep and netcat. So we're moving through Pico, and hopefully we'll get into some of the more fun and hardcore interesting stuff later on, but certainly the first couple of levels are a little trivial and very, very beginner friendly for people that have seen this kind of stuff before. This video is on the Here's Johnny challenge for 100 points. Oh, it says, okay, so we found some important looking files on a Linux computer. Maybe they can be used to get a password to the process. Connect with netcat shell to PicoCTF 4015. 40157, whatever. Again, your host name and port number will be different than mine, so connect with your thing. And files can be found here, password and shadow. So let's go ahead and copy these. I'll download them. Let's make a directory for here's Johnny. And let's wget these files. Blah, blah, password and shadow. Gotcha. All right, so let's check out what this password file is. Looks like it is just the root information here, so the information for the root user. That's just fine. So if you haven't seen this before, this is what we can assume is just a segment or a piece out of the etc password file on a Linux computer. So if I were to check out cat etc password, then you have all the user account information for the things that are on a Linux computer. So my root user here, and that has all those information just like this. The other information that is stored for kind of the login or user account information on a Linux computer is stored in etc shadow, and it's interesting because that's visible from or noted anyway or referred to by this X here, because you have the username in the first column, all columns separated by colons here, and the password is following in the next column, but obviously the password for this user or the root user isn't just X. So the X means that the password is shadowed and visible in etc shadow. So interestingly enough, etc password is world readable. That means that etc password, if I check out the permissions on it, everyone is able to read it. Like root only has read and write, everyone in the group has read, and everyone in the world or all user accounts, anyone has read access to it. But etc shadow is not that way. Only root and the shadow group can read it. Everyone does not have permission to read it. So I would need to be root to be able to take a look at that. I think I can safely head this. I'm going to pause the video to make sure. Yeah, this is fine to show because in the My Ubuntu system, the root user does not have a password, and these other accounts are not things that can be logged into. So in my case, the exclamation point means that root does not have a password in this case, but if we were to check out the shadow file provided to us, which we were able to read, you can see that they supply here seemingly a hash or some encrypted data that represents the password. So we can crack this password or crack this information with a brute force methodology. And that's actually what the hints refer to in this challenge. If you check them out here, it says if at first you don't succeed, try again and again and again. So it's referring to a brute force attack to test and crack this password, or really just guess it, essentially. So the tool to do that is, again, referred to in the title here, John the Ripper. And I've showcased this a little bit before. You can check out John the Ripper. They have a website here, a Wikipedia page that explains a little bit more about it. I'm going to end up going for the repository for the community edition, John the Ripper Jumbo John, I think it is. And that has the GitHub repo that I'm going to go ahead and clone. And it takes a little bit to compile it, but this is what's necessary in my opinion, because you have more tools and more toolkits, like other scripts that will allow you to work with other different kinds of information, like a JWT, a Java Web Token, or some radius information. So everything that will be converted to a format that John the Ripper or simply John can go ahead and read and crack and process. So I'm gonna go ahead and git clone this. If you don't have Git installed in your system, that's totally fine. Just sudo apt install Git or whatever your package manager is. I'll git clone this. Great. Take some time. Let's check out what it says or how to install. How to install. See the install file. Great. All right. Install file. Is that even readable? It's. Where is that file? Is it in source? I would think so. It's still downloading the stuff. Is my internet crappy? What the heck? Install. Oh, no, duh. It would probably be in the documentation. Install Ubuntu. Maybe that stuff is necessary. I'll just do that. So move into source, get some dependencies, get more dependencies, get stuff if you have a GPU. Zoom in a little bit so you can see this better. Clone and build. So really just run configure and make. Okay. and then we can go ahead and run it. I'm going to wait till this downloads. So I didn't end up waiting for it to download. I just went ahead and copied the file that I originally used for my real source files of playing PicoCTF. So suspended disbelief there. Sorry, you can git clone that on your own if you'd like. But once you have it downloaded, move into that repository, and you do want to move into source, just as the installation documentation said, and you would run /configure, and that will take a lot of time to do some things. Like a lot of time, so hopefully you can have some patience for that. And then the next command that it wanted you to run was make. And I think make install would follow that. So they say make clean and make. That's just fine. I already have this actually compiled and made and everything, but I have to disclaimer, it does take a little bit of time, so note that. And once you have it all done, you can move into the run directory, and then you should have all the files and information already completed for you, like it's all compiled and ready to use. So /John is the John the Ripper program. If I run this, it's just John, and it needs some information. But we don't have files that are currently in the format that John the Ripper can actually read and process. So let's check out what our options are. And I'm going to point us in the right direction that we have a utility called unshadow. And unshadow, when it's given a shadow file and a password file, it'll convert into something that John can read. So we can use the password file and the shadow file that's been provided to us from the PicoCTF challenge to begin with and go ahead and create something. So let's move up a directory and work with the password file, move up a directory again and work with the shadow file, and this output is now the format that John can read. So let's go ahead and put that in, I guess, this directory. That's totally fine for us. Let's just use, Pico user.text, and that's totally fine. We'll end up giving that to the John file. John can actually just take that as we want it to, as Pico user, and it'll get started running. /John, sorry. And what this method is going to do is simply brute force. I didn't expect it to get it done that quickly. The other methodology that you could use is a dictionary attack. So the dictionary attack is when you're using a dictionary, right, of passwords or potential things that it could be, and that is what the next hint is referring to when it talks about the rocku file. Rocku, if you check it out, Google it a little bit, rocku is a password list, rocku text, or rocku password list, and that file is ginormous. It's huge. I don't know if it's actually going to take 3 minutes for me to download this thing. You can find it online, and I would recommend downloading it, but it's literally just a plain text file of a bunch of words, a bunch of English words. Let's see if I have it. I know I do, because it's got to be in the... Yeah, let's copy it into this directory, and if I were to cat out rocku.txt, it's a bunch of words, or potential passwords, or stuff that it could be used as a password. So let's go ahead and try that. Let's use John with Pico user.text, and you can say tac word list equals rocku.text. But it sucks because I'm running this already. Tac show. I may need tac show at the beginning. There. Do I have a john.pot file in here? If you end up running John twice and you're actually accidentally kind of not able to view the password that you want to see that you've already, for whatever reason, like uncovered, you can go ahead and remove the john.pot file that's in that directory that you're working with, and that's kind of John's save file. So it won't not do what it's supposed to do again. It'll go ahead and run the process that you would expect. So remove the john.pot file, and you can go back to testing and stuff that you were doing before. So again, John the Ripper found the password is kiss me to the root user. It may be different for yours. So now that we know that, we can go ahead and go back to the original challenge prompt that's explaining to us like, oh, this is something that we may want on the service here. So let's go ahead and copy this netcat command to use the username as root to log in with, because that's what we know what's in the shadow and password file. And the password that we now know is kiss me. We enter that, and we get the password just like that. Let's go ahead and make a get flag script out of this. I'm going to echo root, and then I'm going to echo kiss me. I'm going to pipe those into netcat just like this, and I'm going to cut this with the first field of spaces, but I'm going to reverse it first. So the first field essentially becomes the last field, but now I have to reverse it again. So I've just cut out only the flag that I want. Cool. Interesting technique, right? But that's how we can just avoid some new line characters, just put together some echo inputs and give that to the service that we're connecting to and retrieve that column that we wanted from the flag. So nano get flag.sh, paste in that quick one-liner for us, mark it as executable, redirect that to flag.txt, copy it, and submit it for 100 points. Awesome. This challenge is called Strings for 100 points. It says, can you find the flag in this file without actually running it? You can find the file here at this location on the shell server, but we're given a download, so we can just go ahead and copy that. I will wget it into my directory here, and it's going to take a little bit. I guess my internet just sucks. Okay, now that that's finally done, we can take a look at what this is. I kind of already have an inkling as to what to do and how to solve this considering the challenge prompt, but it looks like an executable, so let's just kind of play along, mark this as executable, and run it. It says, have you ever used the strings function? Check out the man pages. So if you want to check out man strings, you totally could, but it will just print these strings for printable characters in specific files. So we can just pass along the file as an argument to this. So let's run strings, and the file is literally called string. So that's not, I don't mean for it to be confusing, but maybe that's just as we see here. So it gets all the strings out of it. Looks like there's a lot of stuff in here. You could scroll through it if you particularly wanted to, but it looks like it's even more of my terminal history that I can't scroll past. So what I'm going to do is actually just grep again for the flag format, and I will just use PicoCTF with the regular expressions to go ahead and get the insides of the flag, and I'll disable the color there. So simply that will give us the flag. We can go ahead and submit that if we wanted to, but let's just make a simple get flag script for it. So get flag.sh, simple shebang line, chmod +x to mark that as executable. Redirect it to flag.txt, and let's grab it to our clipboard so that we can submit it. Get that 100 points. All right, cool. So let's mark that challenge as complete. Super simple. The next one that we can move on to is called pipe. It says, during your adventure, you'll likely encounter a situation where you'll need to process data that you receive over the network rather than through a file. Can you find a way to save the output from this program and search for the flag? Connect to this. So we're given a host and port number. Let's go ahead and connect to it. What I'm going to do is actually change into the pipe directory that I have already created, and let's connect to that host and port with netcat. So it gives me a lot of garbage. I'm sorry, you're going to have to take another line, blah, blah, blah. This is not a flag, etc., etc. And there's just a lot of stuff. My internet connection is still crapping out. I'm going to pause this a bit. Whatever it looks like, I'll just deal. The methodology can still work here if we actually get results from this service. So what I'm going to do is, just as we've done before, kind of take that output and grep through it. So wait until we get a response that is our flag. So let's go PicoCTF, the exact same format, color equals none, and then eventually we'll get the hit. It should happen pretty quickly on your side. I guess because my internet just sucks at the moment. We'll see how it goes. Okay, out popped the flag, and we can go ahead and do this. If you wanted to, you could just simply save this as our get flag script. It's certainly easier or probably better on your side because your internet will work better than mine. But I'm just going to go ahead and save this and mark it as the flag. We'll go ahead and submit that. Simple stuff, right? Just a strings command, or at least strings command for the last one, and using grep, and this time again using grep to just read through all the output that this service or this netcat connection is spitting out at us. So let's go ahead and mark that as complete. Just burning through these, good stuff. And this next challenge is called Inspect Me for 125 points. It says, inspect this code. It gives us a link to a website, and we can go ahead and click that link, open it up. It says, my first website, intro and about. You can click on these, but there's not a whole lot here. It says, these are web skills I've been practicing: HTML, CSS, and JavaScript. So I'm going to hit Control-U, or you could right-click and just say View Page Source, but Control-U is a good hotkey for it on the keyboard. It says, this is my first website. And you get to see the HTML source. You get to see what the web page is actually made out of and how it's built. So it says, I learned HTML. Here's part 1/3 of the flag. It says PicoCTF, your for real, inspect, and looks like we have to get the rest of it. So let's go ahead, and I've got a directory created for it. I'm just going to start to build up the flag as I find pieces of it. I think we've done this before in PicoCTF 2017, but noting what we just read so far, this person's trying to learn CSS and JavaScript. Let's check out those other files. You can see that they are linked up top over in the head tag of this HTML. So let's check out the mycss.css file. There's some cool CSS, but there's also a comment that says I learned CSS. Here's the next part of the flag. And it looks like that is actually just the very end of the flag. If, like, you can see the format, the ending curly brace at the very end here. And if I actually were to go back and check out the myJavascript.js, it says, here's part 3/3 of the flag, and it's just simply, blank space. So looks like we already just got the two flag pieces that we need from the HTML and the CSS. Let's go ahead and copy that and submit it. Nice and easy. Another simple challenge. Cool. All right, we can mark that challenge as complete, and we've just burned through another couple, like a few of the PicoCTF challenges. So I hope you are enjoying these. Right now, again, the challenges aren't too difficult, but it's certainly good to learn and look at some of the stuff if you haven't seen it before. So I hope it is helping some people. Now we are on the grep 2 challenge, 125 points. It says this one is a little bit harder. Can you find the flag in this location on the file system, on the shell server here? Remember, grep is your friend. So they don't give us a link to download any files here, and we haven't gotten to that SSH or SSH keys challenge to actually connect on our own to the shell server, like through the command line. So I'm just going to do it through their web shell, which I don't particularly like, but whatever. I guess I'll just live with it. My internet connection is still a little awful, so hopefully this isn't too bad. Typing is slow. You will want to just enter your username the first time that you try and connect, and then once you have an account, you can go ahead and connect with that account set up. Oh, forgot my last name here. And then you can log in with the password that you use for the whole PicoCTF game and infrastructure. So now that we were in the shell, we can change directory to, once I right-click and paste from browser, this location. And now that we're in that directory, we can ls and see what we have to work with. We have a lot of files here, or at least seemingly a lot of directories and folders. So what I'm going to do is ls tac r to recursively look through them and see what we have. And we do have a lot of files in here. So significantly harder than the previous challenge when we just did grep 1, right? It wasn't just one file to look through, now we have many. So we can still accomplish this very, very easily, though, because grep offers another flag. If I check out man grep, and I say flag not as the capture the flag that we're looking for, but another argument or something that we can work with. So tac capital R will actually allow us to loop through stuff recursively. I don't know if my shell is actually behaving or I've just lost connection here. Okay, so you could look through the man page, but if you wanted to, you know that we should just use run grep -r or tac r, and then that will give us recursive control. We can still go through lowercase o capital E, so we still get our PicoCTF flag format, and I'm typing this out, but the shell is just not working with it. So hopefully once this all loads, it will just bang out. Okay, awesome. So once we run this, it will find the file for us that has that string, and we can retrieve the flag just like that. So I'm going to go ahead and copy this. I'm going to save it in a local copy, so flag.txt in our grep2 file. Oh, and I totally did not copy that for some reason. Please copy. There we go. Okay, cool. So that way we can mark grep2 as complete. Submit that, and we're good to go. Next challenge is Aca-Shell-A, which is supposed to be a pun off of acapella, and I think this challenge got a lot of hate, and I feel bad saying that. It's not anything. It's not indicative of anything else or anything of the problem designer, but it just seemed like there was some struggle in this that didn't need to be there. So it's never a bad idea to brush up on those Linux skills or learn some new ones before you set off on this adventure. Connect with netcat to this host and port. So I'm going to move to the Aca-Shell-A directory that I have. I'll netcat to it, and hopefully my internet connection handles this. Sweet! We haven't gotten access into the file system, but we aren't root. We have gotten access in the file system, but we aren't root. It's some sort of restricted shell. I can see what you're typing, but I can't see your. I can't see what you're typing, but I can see your output. I'll be here to help you all along. If you need help, just type echo help me, and I'll see what I can do. So let's just actually go ahead and try that. Echo help me with the exact same syntax they have with single quotes and exclamation point. And so you got this. Have you looked for any directories? So I haven't yet. Let's just go ahead and ls, look for some stuff. And these are supposedly directories, so I guess I'll change directory into secret. It says now we're cooking. Take a look around and tell me what you find. So I'll ls again to just list stuff, and it says sabotage them, get rid of all their intel files. So what I'm going to do, rather than going and typing through intel 1, intel 2, intel 3, etc. just by hand, I'm going to use intel, or rm to remove, and then intel underscore asterisk. So any of those numbers will be kind of gobbled up by that wildcard, and it says, nice, now they're all gone, I think I can drop you a file of an exploit. It says, type in echo, drop it in, which we can type for us, and it says, I placed a file in the executable folders as it looks like the only place we can execute from. Run the script I wrote to have a little more impact on the system. So let's go ahead into that executables folder that we knew was there. I can't tab complete. And then now is a new directory. I'm sorry, a new file in this directory. Don't look here. So let's // it because we know that it is seemingly executable, and it spits out a lot of interesting hex for some reason. Maybe it's doing some elite hacker thing. It says, looking through the text above, I think I found the password. I'm just having trouble with the username. Drafts are onto us. We get kicked out soon. Quickly print the username to the screen so we can close our backdoor. Close our backdoor? Whatever, and log into the account directly. You have to find another way other than echo. So what this is referring to is just trying to display your username, like the username that you're running on the computer, or the simulated system that you're in. So you run the whoami command. It says lead hacker. Perfect. 1 second. Okay, I think I've got what we're looking for. I just need to copy a file to a place we can read. Try copying the file top secret in the temp directory into the passwords folder. So I don't know if this has been patched, but I think a couple people tripped up on this, and I certainly did. But kind of the secret was that you had to move into the home directory to be able to properly move this file. I don't know if this was patched. I don't know if this was fixed, but I know there was a lot of complaints about it. So we'll copy from the temp directory this file top secret into the passwords folder. And it says quickly go read the file. So let's go into the passwords folder. We know that top secret is now in there, so let's go ahead and display that cat out top secret, and it gives some spiel on Major General John Schofield and his West Point speech. I'm not a West Point guy. I went to a different service academy. Not that it was any better. And so we have the flag. Cool. Let's go ahead and mark that as complete. So you can kind of base your own opinion off of that challenge. I thought it was peculiar, but a lot of people seem to trip up on it when we really shouldn't have had to. This next challenge is called Client Side is Still Bad. It's another web exploitation challenge. We can assume that we're going to be looking at JavaScript, right? So the client-side programming language. Challenge prompt is, I forgot my password again, but this time there doesn't seem to be a reset. Can you help me? So let's check this link here. I should have opened that in a new tab. It says, welcome to the secure login server. Please enter your credentials to proceed. I'm going to Control U to view the source, see what we're really working with here. Looks like we have a standard MD5 implementation, so we can check out that JavaScript code, but apparently it's not found. Apparently that just doesn't exist. So good to know. Rest of the HTML there is pretty boring and stupid. Looks like it is calling the verify function and then returning false kind of no matter, so that way it doesn't submit a form or anything. But this verify function is defined up here in this segment of JavaScript code. It looks like it just gets the element that we're typing in, so the password field, the password input, right? ID equals pass, get element by ID, get the value out of it, and then it's trying to split up what looks to be the flag in segments of 4, and it's checking, okay, if the substring meets all this criteria, it says you got the flag. This is building out the flag for us, right? You can kind of see it coming to life, and PicoCTF client is bad, is your blah, blah, blah. So let's go ahead and put this together. I'm going to go into Sublime Text, and I'm going to grab with regular expressions anything that's inside of the curly braces here. In fact, I'll just find all and then cut them and then paste them in. So then I can now remove all the single quotes, I suppose, and let's save this to just put it in the client side is still bad. I guess like notes.txt that we could use here. So now we can move into that directory and let's cat out notes.txt, but let's go ahead and reverse all the lines in there. Oh, did I do that wrong? Oh, yes. We want to not reverse each line, but the order of the line. So let's tack. So reverse of cat tack notes.txt, and now we have it all there. So now let's remove all of the new lines, and build out the flag here, and that's it. We can redirect that to flag.text. You could build a script if you want to do that, or just a simple get flag script where you curl the page here. And you know what? Let's do it. Let's go ahead and do some bash magic. Let's curl the page. Oh, I forgot. I have the view source in the link here. My bad. Okay, so now let's just get the first couple lines following it. So let's tail minus n. Is it +1? I forget. I always forget how to get like the last couple lines. Maybe that's not what I want. Let's get the last 20 lines. No. All right, screw it. Let's use head. And let's get the first 20 lines. Okay, cool. Then we can try and run our cut command, where we cut with the single quote as a field delimiter. Let's get the second column here, and let's tail just this 1, 2, 3, 4, 5, 6, 7 lines. 2 minus n. I guess 8 because we want the curly brace at the end. Let's tack s to silence curl. Then let's go ahead and tack to reverse all these, and then remove all the new lines, just as we've done before. So we keep adding on to our pipe, and eventually we will just carve out the flag, just like that. So that is kind of our standalone get flag script, which works pretty well for us, and it does some nice one-liner bash magic, so that's pretty cool. Mark that as executable. We've already got our flag, right? Yep, so let's just pipe that into our clipboard. Go ahead and submit it. 150 points, and we're still cruising. Awesome. Cool. Mark this challenge as complete. I hope you guys enjoyed this video. I hope it was kind of cool. For one thing, just doing some bash magic at the very end there, and then exploring some of the interesting challenges that PicoCTF has. So this challenge is called Logon for 150 points in the web exploitation category. Challenge prompt says, I made a website so now you can log on to. I don't seem to have the admin password. See if you can't get to the flag. And we have a link we can go ahead and connect to. And looks like we have a login page. We don't have any functionality or accessibility to actually like register an account, but we can like try things, and it said admin password, and just kind of as it says, I'm sorry, the admin password is super secure, you're not getting in that way. So you could literally just try like anything, and get in. So let's just go with the classic, and we should be logged in. Perfect. It says, success, you logged in. Not sure you'll be able to see the flag though. No flag for you. Okay, so that's fine. Supposedly we logged in. Let's check that out. The way we can probably do that is by examining HTTP cookies, or the pieces of information and data that a web server will store on your computer, like through your browser, to kind of authenticate you or keep your session intact by some cookies. So I'm in Google Chrome and just using this web browser plugin called Edit This Cookie. If you wanted to just go ahead and install that, you can, just Google Edit This Cookie and add it to Chrome in the Chrome Web Store or whatever. Or you can use Cookie Manager Plus if you're on Firefox, etc., or whatever the case may be. So let's check this out. I'm going to open up Edit This Cookie. I have a username cookie based off what I answered, the password that I answered, and an admin cookie, which is set to capital F false. So maybe this is some kind of Boolean test as to whether or not this account is an admin or not. So just off of a hunch, let's try and change it to true. Go ahead and save this, and I'm going to hit F5 to refresh, and now we get the flag just like that. So, silly, cheesy, boring, whatever. Let's jot that down as the flag. Nano flag.text. Piece it in there. And if you wanted to, we could go ahead and, I suppose, make a get flag script with this. I'm just going to refresh this page, and then we'll go ahead and see. Oh, no, it doesn't give me the... I want to see if I can actually get the request that the web browser makes and just steal it as the curl command. If I were to retrieve this cookie with admin being true, if I set this request now, try and refresh the page, it doesn't happen. Weirdness. Okay, I tried it again, and I think I got a little bit more success here. Now it does give the flag, so let's go ahead and copy this as curl. And I think I just had an extra new line in the cookie editor that I was using. So if I paste this in the browser now, it should give me the entire response, and I can just go ahead and just crap out grep tech OE, PicoCTF with our curly braces as usual, as we're expecting. Set that color to none, and make that curl silent. So just like that, we should have a get flag script. Kind of a quick and easy way, just grabbing it off the dev tools. If you didn't see how I opened that, F12, I think in Chrome, I know for sure will do it. I don't know about Firefox, but that'll open up the development tools, and you can just go to the network tab, and it'll monitor all the requests that you make and as you're talking to a web server. So let's just throw that in a get flag script. Get flag.sh, get a shebang line going, and money. Cool. Let's mark that as complete. Whoa. I can't type. It's cool. Still can't type. Not actually cool. Alright, get me back to the game. Whoa, not that far. Let's go ahead and submit that and get 150 points. Cool, my internet connection is still super duper slow. Next challenge is called Reading Between the Eyes, 150 points. It says, Stegosaurus hid a message for you in this image. Can you retrieve it? So this is, interestingly enough, a forensics category challenge, but the text here and the challenge prompt references steganography. So we have the image. I went ahead and downloaded it already because my internet is awful where I am at the moment. So let's just see what this image is. It's husky.png, and we have a picture of a husky. Cute little puppy dog. A little doge. I would love to get a husky as a dog, but I think me and my girlfriend are to get, like, the actual doge, you know, the Shiba Inu. That'd be awesome. A couple years out. So we could do forensic stuff on this, right? We could run Foremost on this if you really wanted to go down the rabbit hole and think that it was a forensics challenge. However, it is not. Just getting a PNG out of it is that PNG file itself. You could run binwalk on it if you wanted to. You could dig through it however you particularly wanted to. You could run stegsolve on it. That would be kind of something that I would recommend. I'm going to go ahead and copy it here, just java tac jar. If you don't have stegsolve, totally go get it. It's on the internet. It's on GitHub. Just Google stegsolve. Open up the husky image. It's a big picture, so we're just seeing more and more of the puppy dog, but there is nothing in here. Alpha plane is not in there, so that's wrong. The tool that I ended up using with, or going with and using, was ZStag. And I thought this was peculiar because you can check out the hint here. It says maybe you can find an online decoder. And I'm sure there is one online tool to do this. It's probably pretty obscure or something. But I just did it with ZStag. So if you don't have ZStag, you can install it. I think it requires Ruby and Gem. Yeah, there's a GitHub repository and you can explore it a little bit, but I use it all the time because it determines, like, LSB, or least significant bit stuff, very, very quickly and in an awesome way. So let's run zstag on husky.png, and it cranks it out. It immediately finds, hey, here's PicoCTF, here's your flag. Neato. Let's go ahead and just steal that. I'm going to get the first two lines. Let's, oh, I didn't even need to do that. I could just grep for Pico like an idiot. And let's get the field that we want for our flag. Neat. Easy get flag script, right? I do like to write simple get flag scripts. No matter how stupid or trivial or worthless they seem, I think it still documents the solution, or documents the work that we did, and kind of just the understanding of the challenge to, I don't know, just memorialize our work, you know? How can I say I don't know and then I say you know, like as if I've actually made a point? It's weird. I should stop. All right, cool. Got that challenge done. Hope that was pretty interesting. Hope that was kind of fun. Hope that was kind of cool. Hope you're enjoying these videos. I certainly am. We can mark this challenge as complete and just keep rocking for more on PicoCTF 2018. This challenge is called Recovering from the Snap for 150 points in the Forensics category. It seemed like a lot of people struggled with this, or at least I thought I saw a lot of questions about it just kind of flying around. I guess I didn't have too much of an issue with it. Maybe I don't know, maybe I just tried something different and it seemed clear to me, but I've got the file downloaded right here. It's animals.dd, or whatever that may be. So I run file on it and I say that, okay, it's a DOS master boot record boot sector, code offset, this crap, blah, blah, blah. At that point, I see it's some kind of file system, and I could deal with mounting it or trying to handle it or some other stuff. But at that point, I didn't really care. I knew this is a forensics challenge, so I thought I'd go for and run my usual forensics, like low-hanging fruit tools on it. So the first thing I reached for is Foremost, because it's pretty effective. And I went to output, checked out what we got here. Looks like a lot of JPEGs. Cool. Maybe I could carve out files without having to mount the file system or deal with it or crap like that. And I get pictures of cute animals. Look at this puppy. He's adorable. This this fox? That is a fox, right? I don't know why. I don't know why I'm hesitant about that. Little frog here, giraffe, uh, me, bunny, also bunny, and there we go. There's the flag. It just pops right out. PicoCTF, the snap happened. So maybe I don't know. Maybe the foremost tool is not commonly well known. Maybe it is, but I got it just like that. So I don't think it was that difficult of a challenge, but maybe it's just knowing your toolkit, knowing your arsenal, knowing things that can make your life easier, and maybe that just comes with playing a little bit more or just doing stuff. I think we could have gotten this with Binwalk, but whatever the case may be, that is how I solved that challenge. So I'll X-clip this flag, go ahead and submit it, and we're moving. Sweet. Let's mark that challenge as complete. And let's move on. So not too hard on that one. Next challenge is called Admin Panel for 150 points, also a forensics challenge. It says we captured some traffic logging in the admin panel. Can you find the password? So you can download this file. Again, I already have. I don't know what log.txt is. Whatever. Let's check out this file because it is a PCAP file. So that is a packet capture. You can open that in Wireshark if you don't have Wireshark installed. Sudo apt install Wireshark, blah, blah, blah. But it's the best tool for looking at PCAPs manually anyway. So I opened it up without actually supplying the file. My bad. And you'll see a lot of HTTP requests, and you'll note them because of they're green. So you can explore each of them, and you'll notice that the packet information is listed here in the column, and you'll see they were trying to get requests to some kind of page. There's some interesting ones, though, because you'll see a post to a login request, a get to an admin page, so we can follow that TCP stream and explore the original request, right? The clients that's sending it in red, and then what the server responds with in blue. So this is their response. This is what the page returns to them. So it says, welcome to the website. If you were the admin, you would be able to see all your settings here. Neat. Peculiar, but at least we kind of get an inkling that okay, at that packet or at that communication in the server's conversation, that point in the conversation, you can see that later on there will probably be something happening referring to maybe another login or maybe viewing another admin page. So I see this post login, and I figured like, well, it doesn't have any get admin after that, so I figured, well, let's explore what that packet is. Let's follow that TCP stream. And again, you can see red client and blue the response here. The interesting thing is, posting this login, the variables that they're trying to post or supply to the web page are given as arguments here. So you can see user is admin and password is the flag, PicoCTF not secure, blah, blah, blah. An interesting tidbit is that this is just HTTP, right? Not HTTPS. It's not encrypted or anything, so the responses and stuff and the requests that we're seeing across the wire are in plain text. So what we could potentially do is just go ahead and run strings on this data PCAP, and you'll get all the information that you would have had otherwise, at least visible in Wireshark. So what we can do is go ahead and use our magic grep to look for the file format. See if we can get PicoCTF with our regular expressions, and just like that, the flag pops out. So, kind of a neat technique, and honestly, I did that before even opening up the Wireshark, like literally before even opening the PCAP in Wireshark, just because that's a quick and easy thing, good thing to do, right? So, let's create a get flag script with just that, and we're good to keep rolling. Things to note, especially when you're handed a PCAP, like strings is very quick if you're just going to be doing like simple analysis or just trying to find a needle out of a haystack. You know what I mean? Let's mark that challenge as complete. Whoop. Didn't need to use the curly braces because I was supplying another argument, but that is done. Let's actually go ahead. Do I have it? Crap. Let's get the flag out of that and submit. Nice. So in this challenge, we're looking at assembly 0 for 150 points in the reversing or reverse engineering category. It says, what does SM0 or ASM0 with these arguments return? submit the flag as a hexadecimal value starting with 0x. Your submission for this question will not be in the normal flag format, so it's not wrapped in PicoCTF. We're given the source, we can download it, and let's just kind of take note of the function and the arguments that are going through it. So I downloaded this already. I'm just going to go ahead and subble it, open it up in Sublime Text. I'll drag it over to the side here, and I'll create a new pane so I can look at it. I'm sorry, this stuff was when I was testing. So let's say we are running this function ASM0, 0x2a, and 0x4f, and we're given this function ASM0 in assembly here. So this looks like Intel syntax, and I've covered the difference between Intel and AT&T syntax before. But right now we have just a super simple function, it seems like, really, really short, but we're just trying to figure out what is the value or what is being returned here. And in that case is what is the value of EAX, right? So the final value of EAX once we are done at the end of this function here. So we have a little bit of stuff going on. For one thing, we push EBP, or the base pointer, right? And we move EBP to ESP, or the stack pointer. So these two things are the function prologue, right? Those happen at the beginning of every single function. So they're not incredibly important, at least not for what the function is really doing from what we want to see or care about. The next part, it says it moves EIX to be this value, and this is EBP plus 0x8. So we know it's a word, we know it's some, I guess, 4-byte information. I may be wrong on saying that, sorry. But we've got a value at EBP plus 0x. So EBP is the base pointer, right? And we're using that as to where ESP, or where the stack pointer was, and it's pushed onto the stack. So when we get a function prologue, we're building out a stack frame for the specific function. So I want to go ahead and try and help you visualize that over here. Let's say this kind of block that I'm building is our stack frame. So we go ahead and we push EBP to some position on the stack, let's just say right here, EBP, because above that we had all the arguments that were originally pushed onto the stack in the original return address that would be where you would go back to in the code after this function were to exit. So that is what's above the EBP, or the base pointer on the stack. So let's say return address. And now we have the arguments that come that we would have originally passed to that function. Those are also pushed onto the stack before it. So those are the function arguments, or argument variables. How about that? Normally, once you have variables declared also inside the function, you'll have them beneath the EBP, or the base pointer, so local variables. And we can spread this out a little bit if you want here, just to make it a little bit more visible. But what I'm trying to say is that EBP right now is our reference. And you can see that kind of literally in use within the code, because EBP plus or minus will allow us to access different parts of like valuable information for us, like the return address, like the argument variables, or like the local variables. So these are all different. Like these are all separated by each other by a difference of 4 bytes. So when we see EBP plus 4, that means that we're referring to the return address. When we see EBP plus 8, we know we're referring to the first argument that we've passed to this function. Or, because again, that difference of 4, it's just the next one on moving up. When we go to EBP plus 0xc, that's hex, right? It's just hexadecimal 12. So it's just 4 from 0x8. So that would be the second argument that we've passed to this, 0x4f. So that means we can kind of understand what these lines are doing. We can say that now EAX is being set to equal the first argument. So let's take note of that. EAX equals 0x2a, and the numbers may be different for whatever it is that you actually have in your code. But EBX is going to then equal 0x4f. So that works just there. EBX, right? Now we're setting EAX to equal EBX. EAX equals EBX, which ultimately means that EAX is going to end up 0x4f. 0x4f. And then we have our function epilogue, the very, very end of the function, where we say, okay, move the stack pointer back to EBP, go ahead and pop it off the stack, and then return. So that means we're at the very, very end of our function. We'll go back to where we originally were supposed to go because of our return address. But now we know the final value of EAX, or what this function will return, and that's going to be 0x4f, or the second argument that we've passed to this function. So let's go ahead and copy it. Go over here, submit it, and we got it right. Awesome. So that's that. That's just all there is to it. Assembly 0 was simple, right? But it just kind of took a little bit more of an understanding of what a stack frame looks like when you enter a function, and just being able to know, okay, Intel syntax, reading from left to right, these are the arguments that are going through it, and what it returns is, what it really means is the value of EAX at the very, very end. So if we wanted to, we could totally save that as our flag, 0x4f, and that's it. That's all we really need there. So perfect. Let's move that assembly challenge to be complete. And let's move into the next challenge here, buffer overflow 0. So it says, let's start off simple. Can you overflow the right buffer in this program to get the flag? You can also find it at buffer overflow, this thing on the shell server. We're given the source. Okay, so I have these files downloaded already, buffer overflow 0. We're given the source and the binary. Let's check them all out. Yeah, binary is vuln, and the C source code is vuln.c. So let's make the vuln executable. And let's check out what the source code is here, vuln.c. I'll make this one big screen. So we are in the main function. Let's go right there, because that's the very start of where the program will begin. Noting that C code. It tries to open up the flag.txt file, and if it can't read it, it says something is wrong, so that's fine. Looks like we will probably need to run this on the server, so it gets us that flag file that we particularly need. And it looks like it will read it, set up a signal if it gets a psych fault to try and run this sigsev handler, and it'll get the UID and the unique ID, so it looks like it'll get privileges from whatever other owner runs this file, and it'll determine, okay, if we have an argument, if argc is greater than 1, it'll pass that argument, argv1, to this vuln function. Otherwise it says, okay, it takes an argument. So vuln does need an argument. It says vuln, or vulnerable function, takes an input, about 16 characters, and it tries to copy it onto a buffer from our input. So we have a 16-character buffer that we just have to overflow and break, and supposedly it'll handle that segmentation fault once we overflow that buffer, overwrite maybe a return address, as you saw just in that stack frame, because this is a function, right? So its stack frame has this local variable right below EBP, and then right after it the return address. So we have to overflow a little bit more just to overflow EBP and the return address, and then we'll get a seg fault, because our program won't know where to go next if we corrupt the instruction pointer there. And that's what string cup will allow us to do, because it's not going to check the length of our input. It's not using the better version of str or strn copy, where you can limit the amount of characters that it's going through. And in the handler for the function, the segmentation fault, it will display the flag. So let's go ahead and try and solve this, right? Looks like we're going to have to do it on their server, so hopefully we can just copy this location. And I'll try and load this page, and really, really hope it won't crap out on me because of my internet, but we'll see how we do. John Hammond, YouTube. Looks like we're cruising so far. Try and zoom in a little bit so you can see this better. I'll change directory to that location. Go there. And it looks like we have flag.txt that we could look at, but we're not able to read it. If we actually check the permissions here, only buffer overflow 0 is allowed to read it. Like if I were to try and run cat flag.txt, I'm not allowed to. That's why we needed to have that vuln function and the vuln.c, where it is literally grabbing these permissions and trying to set them as we read it. So this program will be allowed to read the flag, but we are not. Okay, so let's try and run vuln. It says it needs an argument, so let's give it a crap ton of A's, right? I'm just going to hold down literally the A key, and it breaks, just like that. That's pretty neat. That's pretty cool, right? So what I'm going to do next is just try and change that argument to some command substitution. So I'm going to use a $ parentheses and do some command substitution. I'm going to use Python, and then tax C to just run a command as Python, and then I'm going to say print A, or lowercase a, whatever we want, times, let's see, 16 was just the size of that buffer, right? And then if I tried to pump that to 20, it says, okay, cool, we received that just fine. And we just overwrote the base pointer. Great. Now, if I were to go one above it, I would start to leak into the return address, because we know that that's a difference of 4, the 4 bytes for the return address, and it literally just some random A character is probably not going to be a location in memory, like even if it just intersects with just a little bit. So let's go 21. Let's see if it breaks. Oh, it doesn't yet. Cool, that's fine. Let's go 22. Whatever. Maybe I'm wrong. I probably am. Let's go 23. Still nothing. What about 24? Are we overloading anything yet? Segmentation fault. Cool. Do I have a flag that's pumping out? I don't. What the heck? Maybe we're not returning this all the way that we should be. This is odd because I'm testing it a little bit more, and I actually got the flag to come out with 29, and it looks like 28 will get it as well, but 27 just gets a regular segmentation fault. So I'm curious what is hitting that handler function and actually rolling it with it, when otherwise a kind of the segmentation fault on its own doesn't call that function. That's a peculiar thing, but I guess that blows some holes in what I was trying to explain, but whatever. Bear with me. I appreciate you guys watching and stuff, you know? So we got the flag. Let's go ahead and copy this. Let's jot it down, and let's save it for this challenge. Nano flag.txt. Great. Move that to be noted as complete. And let's go ahead and submit this. Yeah. Buffer overflow 0, 150 points in the bag. So this challenge is called Caesar Cipher 1. The challenge prompt here is, this is one of the older ciphers in the books. Can you decrypt this message? You can find the ciphertext at this location on the shell server, and I've downloaded this file already. Let's move into that directory that I've created for it. We can check out the ciphertext. It has PicoCTF, like the flag format we would expect, but the inside of the flag is kind of gibberish. So what I'm going to do is actually cut this up. Let's just get that first portion here, and then I am just going to cut the other portion of it out because I don't care what it is. And then I'm going to go ahead and try and loop this through a Caesar cipher. And you could do this with an online tool if you really wanted to. Just find like that decode.fr website or whatever that could break and crack this. But I'm going to try and do it from the command line because I think that's cool, right? So I'm going to pipe this into Caesar tac, I guess whatever number I want. And Caesar, again, is a utility that's installed with sudo apt install BSD games with rot13. I've showed that a little bit ago. If let's just say I want to use 2 or 3 or 4 or whatever, so if I were to just loop through all of those, I can do at the very beginning of the line for I in and bash syntax, you use curly braces to denote, and then 1 dot dot to say a range, and I'm going to go to 26. So let's have a semicolon there to start kind of the code block with do, and then I'll use Caesar $I, so I have a bash variable that will expand to whatever iteration I'm currently looking at, and then semicolon to denote the end of that command, or the end of the, that line in the code block, and then we'll make that code block finish with the done block there. So I'll hit enter, and we got all of these lines pumped out, and you can see blah blah blah, a little bit of English right here. It says just a good old Caesar cipher. Oh boy, oh geez. Okay. And that is what our flag's going to be. So let's just take note of that. Let's just say flag.txt PicoCTF, and I'll paste that in. You could probably detect this however you wanted to in that, but that's a simple way to just kind of get all the solutions. So let's go ahead and submit this, right? Submit. Awesome. All right, next challenge is called environ. It says sometimes you have to configure environment variables before executing a program. Can you find the flag we've hidden in an environment variable on the shell server? Yes. Let's go check out the shell server. I click open this link over here. See how my internet fares. Let's log in here. John Hammond YouTube. Enter my password. My password is password with like all capital ASS. All right, let's change directory. Do I need to change? No, I just need to get the environment variables. So a cool command that you can actually just use to list all the environment variables is simply env. And you'll notice, as we kind of take a look through this, we have mail, path, these things all kind of set up. And there's PicoCTF flag set to nice try, keep looking. But if we just kind of scroll up, you'll see secret flag equals PicoCTF environment variable flag. So since env will literally just display all of it, it's not too hard. We could script this if we were to automate our SSH connection. Maybe we'll do that later. But in this case, I'm just going to go ahead and submit this flag. Let's kind of jot that down, though. We can move our Caesar cipher one to be marked complete, and then we'll just keep track of our environment flag. Just for good habits, you know. Next challenge is called Hertz. It says, here's another simple cipher for you where we make a bunch of substitutions. Can you decrypt it? And it gives us a netcat connection that we can connect to. So let's make a directory Hertz. Get in there. Hertz. What the heck? Okay, cool, whatever. Tab autocomplete was not having my day right now. Netcat, connect, it's all this crap, where there's, the text is seemingly different each time, but it should still, I don't know, potentially give us a flag if we wanted to. I'm just going to throw this in Xclip. If you wanted to, you could kind of copy all of it. But what I'm going to do is I'm going to go ahead and throw this to QuipQuip, which is a awesome tool, quipquip.com, that will essentially solve substitution ciphers, and it's kind of my go-to when I know it is a substitution cipher. So I'm just going to spit this in there, hit the solve button, let it do its thing, run its course, do that voodoo magic, and we should eventually get some solution out of it. My internet connection is still crap. Alright, it says, congrats, here is probably your flag. Substitution ciphers are solvable. Had no bones. I don't know what that last one may be. Boson? Let's get another string. We can go ahead and give it. That's kind of one of the neat things, is that we're getting a lot of these different ciphertext messages that we could use, and we could just keep using QuipQuip until we figure out something that kind of makes the flag format a little bit more understandable. It looks like it is just kind of giving us there it is. Congrats, here's your flag. Substitution ciphers are solvable, and then random letters following that. So good. We can just go ahead and submit that. Wrap it in our flag format, and we've got that one done as well. So perfect. Super, super cool. QuipQuip is an awesome tool, and totally what you should just kind of use as your knee-jerk reaction and low-hanging fruit for substitution ciphers. It's definitely good to know. So this challenge is called Hex Editor. The challenge prompt is, this cat has a secret to teach you. You can also find the file at this location on the shell server. We're given download, so if you wanted to, you can copy the link address, wget it, etc. I've already got it downloaded here, hexeditor.jpg. Let's check out what this file is. It's a picture of a cat. It says, I helped you edit your hex. It's I think this cat is hysterical. I love it. All right, so the purpose of this challenge, right, is to look at this file within a hex editor. So you can look at this in hexedit if you want, the command line version that I like to use. You could look at it in gex, you can look at it in blaise, or whatever you like as your hex editor. If you haven't seen a hex editor before, let's go with hexedit, because that's what I like to use. So I'm going to run hexedit on the file, and in the middle column, the stuff right here, you can see the hexadecimal stuff for it. On the right-hand side, you can see the ASCII representation of some of the stuff. And you can see, okay, it's a JPEG. We got a JPEG header. You can hit page up, page down. You can move around with the arrow keys. Hit tab to switch between the hex side and the ASCII side. And you could go all the way to the very, very end of this file if you wanted to. And you'll find at the very, very end, in the ASCII, it says your flag is PicoCTF, and that's how you hex. That's how you hex, kiddos. and it's silly. That's it. That's that. If you want to do it in a simple way, you could do xxd hexedit, and that way you don't need to see the entire thing in its own buffer thing. You could use tacp to just print it all on one line, and if you wanted to, you could use tac. What is it? Maybe that'll just display it in hex. Whatever. What we could do otherwise is just display the plain text that we're seeing out of it with strings, which literally you could get the flag just like that with strings. Get the very, very last line, cut it up with the double quote as the delimiter here, and that's that. That's how you could literally just get the flag with the strings command. So pretty handy, right? Let's make a get flag script for that. Super simple. And then we can run it, redirect it to a static file to keep track of it. Let's clip it so it's in our clipboard, and we can go ahead and submit it. So that's simple. Nice. Next challenge is SSH keys. It says, as nice as it is to use our web shell, sometimes it's helpful to connect directly to our machine. To do so, please add your own public key to SSH authorized keys using the web shell. Flag is in the SSH banner, which will be displayed when you log in remotely with SSH to your username. So we've done this before in PicoCTF 2017, right? It's not too hard, it's not too difficult, but an interesting thing happened where if we were to just use this domain, 2018 shell, maybe not 2 if depending on your account or whatever, or just 2, whatever. You can just simply SSH to it if you wanted to. Let me mark hex editor as complete and I'll show you. Or if you wanted to just run SSH to this thing, you could get there. And if I were to just say my username account, right, John Hammond YouTube at that host, sure, I'll accept this key, and it just gives me the flag right away. I don't need to do any SSH private key setup. It's kind of like suggesting within the challenge prompt. So that I thought was odd, and maybe it's not. Maybe it's intentional. Maybe it's not intentional. I don't know. Maybe it's going to be patched or fixed later. But that's just what I saw. So let's jot that down in the SSH keys challenge here. Save the flag for ourselves. I don't know if I have a new line in there, so I want to copy it one more time. We can paste it in, and just like that, simple stuff. So we didn't have to go through that whole process, although there is a lot of good documentations and stuff how to do it. I have a video from the 2017 SSH Keys Challenge, and again, Mr. Martin Carlisle has a good video on it too. You can check out some of his stuff. Cool guy. Awesome guy. Irish Name Repo is the next challenge. It's a web exploitation category challenge. It says there's a website running at this address with the given link. Whoa. Sorry. I didn't mean to just kind of jump the gun on that. Do you think you can log in? Try and see if you can log in. Whatever. Let's open that in a new tab. The list of the Irish. That girl is a girl that is Alison Doody. Nice. All right. There are pictures here of Irish people, and it's funny, there are more pages, except they're not. I was really sad when this was happening, because I just want to look at more pictures of preferably people that look like that girl. So there's a menu. There's a little hamburger button over on the top left that you can check out, and there's an admin login page. So you can go to login.html, and you can try and log in with some usernames here. Let's just try default credentials, admin and password. Login failed. So you try whatever you wanted to, but that's just not going to work here. So the hint in this is it says, there doesn't seem to be any way to interact with this. I wonder if the users are kept in a database. So that's your clue as to what kind of attack this is. It's SQL injection. SQL injection being SQL, right? So structured query language, how you're interacting with the database or like structured queries stuff. SQL injection will kind of just allow you to inject specific database code or SQL into maybe how the server will interpret it, and you'll trick the backend server to thinking that what it would have expected as data, just what you are supplying, except it's really code. So we can even use some of those easy, kind of low-hanging fruit, simple ones with an or 1 equals 1 or a condition that always returns true. See if we could log in. So I'm going to try that just here. You can comment out the very end of it, and I've covered this in a lot of other videos before. You can see it in plenty of PicoCTF 2017 videos. It logs us in with the password. Awesome. It says your flag is PicoCTF. Conan really isn't Irish. Nice. That's funny. If you wanted to, you could write a get flag script for that. I'm not going to for this one. Irish name repo complete. I think that was the name of the challenge. Paste the flag in there. And we'll get back to scoring points on the scoreboard. I love it. Hey, what's up YouTube? My name is John Hammond. This is another video write-up for PicoCTF 2018. This challenge is called Mr. Robots for 200 points in the web exploitation category. Challenge prompt is, do you see the same things I see, the glimpses of the flag hidden away at this link? So we can go check out this website. It says, Mr. Robots, hello friend. So I'm just going to glisten from the challenge title and the name here that this is a reference to robots.txt. So if you haven't seen that before, I cover it in a lot of videos because it's kind of just the most simple, low-hanging fruit web challenge classic thing you can find in a CTF. So it's just a text file that explains pages that would not be kind of visible to a Google bot or kind of a web spider or crawler that's trying to index pages and stuff like that. So we can go ahead and check out that robots.txt file. Let's go to the /robots.txt in the URL. It says, for any user agent, so for any kind of web browser, go ahead and disallow this page. Don't allow them to get to that page. They're trying to hide it. But it is plain text. We can all see it. It's all accessible. So much depends upon a red flag. We can just go ahead and grab this flag right there and submit that. So if you wanted to, we could go ahead and make a get flag script out of that. Let's go ahead and just write like curl here. Go ahead and curl s this, and then let's get our flag format out of it. Super duper easy. All right, just like that, we can save it. Again, my flag will be different than yours because of the hex at the very, very end. I should have marked that as complete. My bad. Get flag script, bin bash, paste that in there, mark it as executable. Go ahead and run it, save it, and mark that challenge as complete. Easy peasy. All right. The next challenge is called No Login for 200 points. It says, it looks like someone started to make a website but never got around to making a login. But I heard there was a flag if you were the admin. So this challenge got a lot of flack. No one particularly liked it, at least from what it seemed like. It says, I'm sorry, it doesn't look like you are the admin. I think this was kind of a guessing challenge or a leap of faith challenge, and that's why I think it got so much flack, because sign in and sign out aren't available. If you try and go to the flag page, it says you're not the admin. So what we ended up having to do was creating a cookie. So I'm using edit this cookie. I'm just going to create a new one here. The name will be admin, and I'll set the value to 1. And now I refresh, go ahead and hit the flag button, and it gives me the flag just like that. So no real inclination or no real kind of point to do that. Just maybe from your learning in the previous challenge where you had to modify the cookies. This time we had to add a cookie, kind of guess the value. The name would be admin, and it set it to 1 or true, and you'd get a flag. So dumb, not my favorite thing, but whatever. I'm just going to bang out a quick script for that. Let's make a directory, no login, and I'll mark it as complete now because we know we've already got it. No login. Complete, and I just created a script, a Python script for it, because I just want to be able to specify those cookies. User bin environment Python. Let's go ahead and grab the URL. URL can equal this. Let's import requests, which if you don't have installed, you can sudo pip install requests, and if you don't have pip, you can sudo apt install python-pip. And let's just do requests.get URL with cookies. That's a keyword argument I want here. Let's say admin and set it to 1. And let's just say this is R for a response variable. Let's print r.text. Looks like we do get the flag just visible there. Okay, so now let's go ahead and carve it out with some regular expressions. So let's do re, and then re.findAll PicoCTF star asterisk to get it all, and we get that as our input, and we can go ahead and print that out. So perfect. Let's mark that as executable. Redirect it to flag.text, and we're done with that. Awesome. All right. What's the next challenge? Do we want to submit that? Do I have it in my clipboard still? No, I don't. Too many alt tabs. Alrighty. Now that that one's done, let's check out Secret Agent for 200 points. Another web exploitation category challenge. Here's a little website that hasn't been fully finished, but I heard Google gets all your info anyway. So we can check this out. My new website, hit the flag. It says you are not Google, and it gives us our user agent, or the header that's passed through HTTP or whenever you try and make a web request, about what kind of browser that you're using. So it sounds like in this case we want to act as if we are the Google bot or the Google crawler to index stuff, like as if we were viewing the robots.txt file. So let's try and figure out the Google user agent. Let's try to Google what the Google user agent may be. And Google crawler's user agents, I had to poke around with this a little bit. I think eventually it was the Google bot or Google auth thing that worked. Not sure which of these. Maybe. Let's try this guy. So what I'm going to do is I'm going to take this web address. I'm going to go to my terminal here, and I'm going to use curl to go ahead and get the page. It says, you're not Google, and it says curl is our user agent here. Let's specify a user agent. Curl can use tac user agent, and then I'm going to go ahead and paste in this information here. And it says, awesome, here's the flag, secret agent. So that one worked just fine. I use the user agent in curl, and you could do this if you wanted to with another Python requests module stuff. You can say headers can equal curly braces and then the header. So you're just setting up a dictionary for the headers that you want to supply, and you can paste in the header that you want. And then in your request, you would simply say headers equals headers. Or if you want to use a dictionary inline, you could do it just like that. So interesting thing, but I'm not going to go through that one. I like the curl style here, and then we can just grep for our flag. Carve it out. And if we're going to grep, we need curl tac s. Oh, my processing was weird there. Awesome. And now that is our get flag script. Let's make a directory for that. It's called secret agent. Mark it as complete. And bang out a get flag script with our proof of concept stuff that we just did. Awesome. Redirect that to flag.txt. So that's that. Some cool web challenges, some simple stuff, just kind of knowing your toolkit and knowing what is able to crank through those for you. I think that it's kind of awesome to just know how we can manipulate those headers and those cookies whenever we need them, especially in code and in automation. So doing that in curl or doing that in Python is just going to benefit you later down the road for a lot more of these CTF style stuff. This challenge is called Truly an Artist for 200 points in the forensics category. It says, can you help us find the flag in this meta material? And you can find the file here, but we are given a download. So I have downloaded this, and just judging by the challenge prompt, I think we're going to be looking at some metadata. So let's check out what this file actually is. It is just an image file, right? PNG file or the logo, and we could do some stuff with it. If you want to run strings on it, you could do some anons. Looks like that actually pops out the flag pretty easily too. So the go-to here, right, in this is running ExifTool, and if you don't have ExifTool already installed, just sudo apt install ExifTool, but it will allow you to view metadata, right? So you can check out the man page for it. Why did that give me Vim? That's weird. Read and write metadata and meta information in files. So ExifTool on this file will give you the artist, right? Hence the challenge title, Truly an Artist, with PicoCTF look and image. So it turns out strings will work on it very easily too. So let's go ahead and just grep for our flag format and pump that to a simple get flag script. Pretty easy. Not too hard of a challenge. So, cool. Let's actually follow through with all that. Let's chmod. I have this horrible problem sometimes when I'm recording. I wear a headset, right? And sometimes my ear starts to itch, and it's kind of bad. I like pause the video and just like itch my ear. Weirdness. Let's go ahead and submit that. This is as real as it gets, guys. This is solving CTFs for realsies. There's no filter in John Hammond videos. All right, assembly 1 is the next challenge. It says, what is SM1 0xCD? So some hex value return. Submit the flag as hex. Okay, so we've done this before in assembly 0. Let's check out what this is. We have a source file that we can download, and I have it in assembly. I don't have it, actually. Let's go. Let's W get it. When I recorded earlier, my internet was awful, so I tried to download a bunch of stuff, but I guess I just didn't get this far. We can wget it real easy, get the link, and let's check out what we're working with here. Let's set the syntax to assembly, and if you aren't using Sublime Text or whatever, you can, if you are using Sublime Text, you can install that package. If you don't know the package manager, you can find that on Google or whatever. So SM1, sorry, let's take note of what we're trying to call this with. Just leave this comment here. So 0xcd. We have, let's go through this line by line, right? Function prologue, as usual, and let's do this in a, no, let's do it in a one page. More function prologue, and then we determine if our first argument, right, we cover that in assembly 0, is greater than 0xde. These numbers may be different for how you're working on it, because just they're really cool random generation of challenges. So let's say greater than 0xcd should be greater than 0xde, and we can use Python to test these values, and that's false, so we won't jump to part A. Now we test if ours is not equal to, simple, 0x8, and that's obviously true, so we're going to go to part B. So let's jump down to part B. We'll say EX is going to equal our argument, so EX can equal 0xcd, and then we subtract 3 from it, so EX will now minus equal 0x3. So doing that, we have, oh, let's put that in hex, 0xCA, fine. And now let's compare if our argument, right, is not, so not 0xCA, but 0xCD, if that is not equal to 0xEE, which we know it is not. So we will jump now to part C. So part C will take EAX, which again is now being set to our original argument, so 0xcd, and now we'll add 3 to it. So now we have EAX plus equals 0x3. So we want 0xcd, our original argument, plus 3, and then let's just turn that to hex, and 0xd0. Now we go straight to part D, because we don't have any conditionals, we're not jumping anywhere, it's not branching, and we have our function epilogue. Okay, so our final value of EAX should be 0xd0 in my case. Let's go ahead and try that. Let's submit 0xd0, and I'm wrong. All right, what did I miss here? Oh, I completely forgot to jump to part D. I don't know why I just like mentally missed that line. I'm an idiot. I'm sorry, guys. I didn't mean to lead us all down that rabbit hole. That was stupid of me. Let's just go ahead and take our original argument minus 3, because after we subtract, then we go straight to part D and end the function, so we don't even need to worry about part C. My bad. I'm sorry. This is as real as it gets. Cool. That's correct. All right. Thanks for bearing with me. I hope that wasn't too awful. Maybe it was still good for us to go through that process and read through some assembly together. Hopefully that's still cool. Hope you still love me. I make mistakes. I'm human. It's whatever. The challenge is called Be Quick or Be Dead number 1 for 200 points. Challenge prompt is you find this when searching for some music, which leads you to Be Quick or Be Dead 1. Can you run it fast enough? And you can find the file there. So this link is really funny because it just brings you to an Iron Maiden music video. I don't know if I can show this copyright. Just some guys going crab core. It's pretty cool. I thought it was funny. I liked it. And you can download this Be Quick or Be Dead file here. So I've got it downloaded already. We actually just see it isn't executable, so let's mark it as executable. Be Quick or Be Dead. And then let's run it. It says Be Quick or Be Dead 1, calculating key, you need a faster machine, bye-bye. Okay, that sucks. So if you wanted to, you could try and reverse this thing. We're not given source code, so I'm going to use Hopper because that's kind of my go-to, although IDA is probably a good thing to do. What am I? I'm in YouTube Pico, and Be Quick or Be Dead 1. So if you're in Hopper, you can go ahead and check out like printing flag, stuff like that. Print flag. You can just go to the procedures and check out the main function and see what we actually have to work with here. I'm going to go ahead and hit Alt and Enter so we can see what we're working with. Header will simply just puts and print out on the screen, be quick or be dead. Do a for loop to print some characters, then puts, and that's it. Set timer, and what that does is it tries to set an alarm for, I'm assuming, 1 second, just like that's what that is. And with that alarm is set, that's the go ahead and receive signal to exit. And once you exit, it says, well, okay, you need a faster machine, right? This alarm is what's going to happen. And where's that string? Actually, I want to see where that function is. It says you need a faster machine. Bye bye. That's in alarm handler. So it has this variable. It has this function. Sorry, alarm handler, where it's being set and using it with the alarm. So after a second, it'll call this and immediately exit. So that's annoying and stupid. We could patch it if we wanted to. But otherwise, we would just simply get the flag, right? You check out the main function, just as where we were, and had that alarm not actually called, we would get key, as it says it's trying to calculate the key, and then once it's actually ran calculate key, whatever time this takes or whatever it's necessary to do, eventually it will go ahead and try and print the flag. So the flag is already in the binary somewhere. It's decrypting it somehow with that function. So who cares? Let's just see if we can avoid getting around, let's see if we can avoid that alarm handler. So what I ended up doing is actually just running this in a debugger. Like GDB would just seem to do it just fine. I don't know if because I have PETA enabled that is why it was working for me. I'll try it with PETA because right now I have it with PETA, right? And if I were to remove PETA, maybe it won't work. If you don't know what PETA is, by the way, I'm sorry I keep saying that word over and over again. It sounds very silly. That's not what I meant. GDB PETA is the Python Exploit Development Assistance Toolkit thing for GDB. So let's see, if I just run this, it will try and calculate the key. It'll receive the alarm, and it'll handle it, but it won't end the program. So we'll just spit out the flag. So that's pretty awesome. That's pretty neat. That's pretty good for us. Let's just take note of that flag. And if you wanted to, you could jot down like a solution.txt file because I'm not gonna script that. That'd be stupid. Let's see if I can change my GDB init file and not run PETA. So if I just run simple GDB now, GDB with be quick or be dead, simple run. Nope. It looks like I need PETA. Okay, peculiar thing. That's fine. Good to know. That's why I showed it to you. PETA will handle it just fine, and it won't quit out of you once you receive that alarm signal. So all you have to do is get the repository, echo, run that script in your GDB init, just as you saw mine, and then it will do its magic. So I think a lot of people like Pwn debug as well, or other, well, Pwn GDB, other add-ons for GDB that are kind of nice and awesome. I haven't used enough of it, and I'm not that good of a binary exploitation guru or ninja yet to really know it or use it that much. But PETA always seems to be okay for me, and it spit out the flag for this challenge. So neat. Let's mark that as complete. The next challenge is Blaise's Cipher. Let's submit the flag, sorry. Oh god. I don't know if you saw that. I had some technical difficulties for a second there. Alright, cool. Blaise's Cipher. My buddy Blaise told me he learned about this cool cipher invented by a guy also named Blaise. Can you figure out what it says? Connect with this thing. So, Blaise Cipher, right? Google it. It's a reference to the Vignir cipher because it was created by this guy named Blaise. I mean, I would hope that's how you pronounce his name, whatever. So, whenever you hear references or you hear notions of Blaise or the cipher indecipherable or the indecipherable cipher, that's all kind of a pointer and a hint in reference to the Vignir cipher. And I'm probably pronouncing that wrong. Vignir, meh. Folly. Do I have Blaise cipher already created? Nope. Blaise's Cipher. Let's go ahead and try and connect to it, and it pumps out a bunch of gross information. That's fine. It's gibberish. It's Vignir Cipher. If you wanted to, you could use some online tools, right? Vignir Cipher Cracker. decryptor or whatever, decoder can do it, my geocaching profile can do it, and then try and determine the key once you paste it in here. Geocaching profile takes a little bit of time. Let's see if the one here on decoder will work it just fine. Yes, looks like flag is fine, but it won't give me all of the text, so we will probably end up using my geocaching profile. And the key is flag, right? And it's repeated over and over again. So now that we've figured out that, we can supply it. Shift using this key, flag, and run it one more time. You could use the script that we've created in other videos. TJCTF, I think I showcase how to use it. But you can see the flag right in here. Figuring your ciphers aren't bad with that original key. So submit that, and we're good. Oh. Does that need to be... Oh, capital letters for the CTF flag. Win. Awesome. That's a peculiar thing about Veneer Cipher as well, is that it always wants to handle things in one specific case. So see how everything is uppercase in this or lowercase in that? They will try and handle it as either lowercase or uppercase letters. And it normally tries to remove punctuation to deal with stuff. So peculiar, but good to know and play with. Buffer overflow 1. Okay, now you're cooking. This time you can overflow the buffer and return the flag function in this program. Sweet. We're given the program and the source code. We can download it. I've already wget it, but we'll have to run it on the shell server so we can actually receive their flag file just as we've done before. So let's go check out what we've downloaded here. We have the source file, so let's go vuln.c, check it out. It will define some macros here to kind of have a buffer size and flag size. We have a win function that will just print out the flag file. Okay, looks like that's how we can get the flag. And the vuln function is just running gets, which we know is a very dangerous function. We can check out man gets if we wanted to. Man gets. And it says never use this function because it has significant security problems. Sets a buffer up, raises our privileges so we can run on the server and get the flag, and then it runs the vulnerable function. So it'll jump to an address, and that's pretty cool. You can see this gets return address thing. So that's neat. Let's go ahead and try and run this function, see if we can work with it. Let's mark it as executable. Vuln, please enter your string. Awesome. And it says, okay, time to return, and it will jump back to where it expected to return to in the program. I could write please subscribe or whatever stupid stuff, but we do want to try and overflow this, right? Given the actual buffer size, so 32 characters. You can see I entered a crap ton of A's, and it says, okay, time to return, fingers crossed, we're jumping to this location. So if you didn't have this output, you could run dmessage and then actually get the very last couple lines of it, and you can see where your seg fault is happening and how much you've actually overflowed EIP, or the instruction pointer. So you're overflowing the return address, as you've seen on the stack. We break through the local variables that we're receiving. We're going to end up overriding EBP, and we're going to end up overriding the return address, so EBP plus 4 on the stack frame. So once we have a return address controllable, that way we can jump to whatever function we want. Let's go ahead and try and return to the win function. So first we need to know where that function is, and I'm going to use readelf tech s to just view symbols on this binary here, and we can see we do have a function called win, and it's at this location. So just as you saw when we ran vuln without anything big, and we'll just jump to a location back to main, or location where we were in main, we can also jump to the very start of win, and that's exact same kind of style of where the constant is in the binary. So we can just set that in little endian format, and then go ahead and try to actually jump to it. But we need it in little endian format, right? So you can do this with Python, or you could just kind of do it by hand. But Python with the struct module, which is installed by default, you can use struct.pack with a little endian, so less than sign, and a capital I for integer, and then you'll supply this as a hex number, and you'll get some information like that looks kind of random when you have it displayed on the terminal, but that's because it's just hex bytes. So if I print out the representation of it with repr, you can see it's the \x and location in hex. So that's cool, right? Let's go ahead and try and find where our offset is, or where we can go ahead and overflow this and actually run the win function. So we would go ahead and Python text C, where's that print statement? Let's also do print A times, let's say we know our buffer is like 32, so let's go maybe like 36 or 40. And let's add on that string. And let's pipe that into vuln. And it says, okay, we're jumping to this location. Maybe we didn't override it just enough. 44. And we jumped straight to the location that we wanted to. And we know that because it's trying to cat out the flag file. Since we're testing locally, if we wanted to, we could create our own fake flag. And I do this a lot. I'll be like, John, please subscribe, or like John wins, or like John got the challenge, or whatever, and we will print out our local fake flag. So that's a cool way to do it. Now that we know we have this payload that will work, let's go ahead and try and connect to the server. So what I'm going to do is actually create a simple SSH script that will get me to where I want to be every time, and I won't have to try and like SSH the same command every time. I just want 2018 PicoShell, and let's create in the above directory just an ssh.sh script. I still want to be able to enter my password. Whoa, I didn't want that. I wanted this. SSH John Hammond YouTube there. And let's keep this back in our clipboard. Mark that as executable. And now that we can connect to it, we'll enter our password. We're logged in. Let's get this just kind of in our directory, or just output, so when I go back to get to the actual problems page, I can copy and paste it pretty easily. Let's get to buffer overflow 1, and we'll get to this location on the file system. We'll just copy and paste it. So let's cd over there, right? Now let's run the same command that we had. It says, okay, time to return, fingers crossed. We have overflowed, and we've told the return address to overflow and instead be our win function, and it pumps out the flag because we've called the win function just like that. Addresses are easy. Slick. Let's do that. nanoflag.txt, save it. Let's remove our cheesy please subscribe file. Submit it. And that challenge is now complete. What a win. Let's mark that as complete. Overflow 1. Complete. Sweet. I am just going to solve the next challenge because it's pretty simple. It's the identical, same thing, like same solution as the last Hertz challenge. Hertz is another substitution cipher, right? Just as we saw in the last one, so let's make directory Hertz 2. Hertz 2. Go ahead and netcat to it, get this string, and we can, again, just slap this in quip, and it works just fine for us. We will get the flag pretty easily. Substitution ciphers are easy. If you wanted to, we can get every other part of it and mark that, like say what that is. And then it should know that the rest of that string, it should be able to figure out what those question marks are. Because the clues will allow us to just say PicoCTF substitution ciphers are too easy. Let's solve it now. And then now that it's able to figure out all those letters, it can get the rest of the flag. Kind of a cool trick. Stop refreshing so I can actually highlight this. Oh my goodness. I hope you guys are having fun. I hope these are entertaining as entertaining as they are educational, because I'm an idiot. That's all. All right, let's do nanoflag.txt, save it, and we're good. Hertz 2. complete. And that's that. Thanks so much for watching, guys. Hope you enjoyed a little bit of buffer overflow. Some cool stuff. I've done those a lot before in Ryan CTF, Ryan Nicholson CTF, and other competitions. So there are plenty of videos on it, but that's how we could just run through it for PicoCTF. So this challenge is called Leak Me for 200 points in the binary exploitation category. It says, can you authenticate to this service and get the flag? Connect with this, and you're given the source code and the binary. So I've downloaded both. I've got them here. Just, see source code and a binary. So let's go ahead and mark that binary as executable, and let's go ahead and check out the source code. So they have a flag function that will just simply pop out the flag. Awesome. There's a main function that will allow a buffer to be created and set the permissions so we can elevate our privileges once we actually run this on the server. And then it has a real password that it's actually being able to read out with some buffers set up. Looks like it will create these buffers kind of by hand with memset, and it will ask, what is our name? Then we'll try and read our name with the length of the name, right? So 256. And interestingly enough, what it does here is it tries to check for the very end of our name based off where the new line is. So once we hit enter, it'll read in that new line. And if it goes ahead and finds that, if it finds the position, what it will do is it will go ahead and set that to a null byte character. If it's not there, then it will just say, okay, it's totally fine how it is. It will ignore it. So that's a peculiar thing, and that is where our potential vulnerability lead will be. Then it says, please enter the password. It will go ahead and open up the password and display it if it actually has it available. And an interesting thing is we could take advantage of this locally because we're actually seeing some string compares being used between the password and the real password. And otherwise, if we get the right password, it will give us the flag. So let's go ahead and try this, right? If we wanted to run this locally, we totally could. Let's say auth, what my name, John Hammond. I'm just kidding. My name's please subscribe. Password file is missing. So if we were to create a password.txt, please subscribe again, then we could run this, say John, and then hello John, please enter the password, anything, which we know is wrong, and it'll say incorrect password. If we check this out with ltrace, we could see all this stuff happening. So if I said fgets what's my name, John, please enter the password, anything, we would see it actually do the string compare and we could find the password. However, we don't have shell connectivity in this challenge. We can't really run ltrace on the binary. All we have is this netcat to a connection. But we found a peculiar thing where we were able to leak out the password, potentially, if we just don't have a null byte character that ends our name variable. So we got to keep in mind, our name variable is 256 characters long. So if we actually fill out all of those, and it won't be able to place a null byte character or terminate that position there, that string, we will potentially read out the next variable on the stack, which is password, right? Password is actually going to have that null byte, so it'll properly display the string if we actually were to overwrite the one in name. So we could leak out the password just like that. Let's go ahead and try it. We will need about 256 characters of anything, right? So all of these, we'll give that to our auth, we read it, and it will say the password that we already have, literally just stored in password.txt. So that's a peculiar thing, right? We could go ahead and pipe that to the connection, and we'll leak out what the password should be. So now that we know that, we can go ahead and actually interact with this service for real, give it any name, please sub, enter the password that we know, and we get the flag. So, just like that. Cool thing. What I'm going to do is actually display this in a getFlag script. I'll just enter the password with the user line and stuff like that. So we'll read those out. Oh. What was wrong there? Oh, the $sign. So let's use a single quote. Works. Let's get tail tac n1. Gotcha. And that is our getFlag script. I use printf so I could use the new line characters. You could just as easily use two commands of echo and put them together in parentheses and semicolons. I know I've done that before too, but it's whatever you're particularly comfortable with. I suppose it really doesn't matter. More than one way to skin a flag, skin a cat, skin a flag. I don't think that's how you say it, John. Skin a cat in Linux. Cool. And we've got that challenge done and over with. 200 more points on the board. Next challenge is called Now You Don't, which is not too difficult, so I'm going to actually just bang it out in this challenge, in this video here. Let's mark leak me as complete. Sweet. Now let's make directory for now you see me, Or no, you don't. No, you don't. Sorry. Oh, it exists because I probably pre-downloaded it. Yep. So let's check out what we have here. Just a PNG file. Let's check out what it actually is. Looks like a picture of just red. So what challenge is this? It's forensics, whatever. I guess I'd consider this more steganography. What we're going to use is just kind of actually verifying that that is all red. So I'm going to go for my StegSolve tool. Easy, low-hanging fruit. If you don't have it, Google it. You can download it just fine. It's just a jar file. So what I'm going to do is locate StegSolve. Let's grab it. Java tac jar to run it. Hit O to open files in the current directory, and you say now you don't open the file. So we got red, and we can view through all these different planes here, or all these different ways of viewing the file. Once we get all the way to red plane 1 or red plane 0, you can see the flag. So let's go ahead and jot that down. Flag.text. Now you see me. So that's the joke. Now you see me, now you don't. Oh boy, I can't type. 533 to 3. Great. And that's that. So we can submit that, and we're cruising. Another win. Mark that challenge as complete. And if you wanted to, you could write a simple solution.txt, so you remind yourself what you did to win that and solve that challenge. This is the challenge quackme from PicoCTF 2018. I'm going to try and spend a little bit more deliberate, dedicated time to this because it doesn't have a whole lot of solves, and I think tripped a few people up. So let's take a look. It says, can you deal with the duck web? Get us the flag from this program. You can also find the program at this location on the shell server, and we have a link to download it. So I can wget it if I wanted to. I've already got it downloaded though, so let's take a look at what we actually have to work with here. If I run this binary, it says, you've now entered the duck web, and you're in for a honkin' good time. Can you figure out my trick? Some input, let's just say, please subscribe, and then it says, that's all folks. So, okay, what do we do here? If we wanted to, we could check out the hints. It says object dump or something similar is probably a good place to start. So this is in the reversing category, right? This is a reverse engineering challenge. The challenge is called quackme, and I think that that is a reference to a crackme, or as in kind of like, binaries that are meant to be reversed and understood, and just trying to kind of manipulate it or trying to find out the key or the correct input that will actually solve it for you, like trying to pick the lock. So interesting thing. Let's open it up in Hopper, and that's what I'm going to use as my, I guess, static analysis program here. Let's go ahead and open up the YouTube Pico for quackme. Quackme, there we go. Open up main, and let's jump to our main function over here. And I'll just check it out. I'm going to hit Alt and Enter so I can decompile it, or at least try and get pseudocode. So it sets a buffer up here that works just fine for us, displays this line of text, that string that we saw earlier, and then tries to run this function called do magic, and then puts that's all folks. So do magic is probably where the magic's at. Let's go ahead and just copy this code because I want to be able to manipulate it. There's a lot here, right? So we want to be able to reverse engineer it. I'm going to work with it in Sublime Text, just so I can actually handle it and understand a little bit more. So that way we can get syntax highlighting and it's nice and pretty and stuff. So this is our function, do magic. It looks like it takes in our input from this function, read input. So let's set var14 to be our input. Good. And var10 looks like it's just taking the length of it. So let's change that length, or that variable name, to length of our input. I'm using Control H, by the way, and then Control Alt Enter just to be able to make rapid changes throughout the entire thing. It gets the stack pointer, and it tries to allocate some memory with the length of our input and +1, so probably a null byte at the end. So let's just say that var_c is actually memory for our input. Control Alt Enter, and then if it is not 0, so if it's able to properly allocate it, it will jump to this location. And this location sets up memory for our input, length of our input, and it looks like it's just trying to, okay, allocate. So initialize input. How about that? We'll just call that Control H, initialize input. Sweet. So once we're initializing our input, we actually set some variables here that I'm just going to consider var18 and var1c, whatever. We'll just call these 0 since they're just being initialized to 0, we'll call them 0 for now, and then if we understand them anything more later, then we can change the name. And this can also be a 0 var. 0 var 2. Okay, and then we go to this location. So this location tests if EAX is 0 var, length of our input, otherwise it will go to some location and go to .L1. Where's that at? Oh, so go to, let's call that .L1 can just be end function, or like, so if our length of input, if EX is our length of input, we go to this location, and this location will do something. Looks like it's testing 0 message. There's a 0 var 2 added onto our greeting message, and the memory address at 0 message, so it's trying to get a specific character out of the greeting message, and it's ANDed with 0xff, so it's just going to be a single byte. And if it's equal to our input plus 0 var 2, so 0 var 2 must be doing something. Looks like it actually, okay, that's got to be an iterator, right? We can actually see this location down here. Increment. So let's just change this to increment iterator. And then 0 var 2 will actually just be called our iterator. And then it will go back to, okay, test. Go back. If after it's iterated, we'll go back to test length. If EX is equal to less than our input, and otherwise it will go to, so length of our input must be 0x19, right? Because it's 0 var, another 0 var, so this got to be another iterator. Where else is 0 var being used? It's not. Oh, it's just being used as a counter to determine whether or not we're going to continue to iterate. So we have a loop here, right? Like I think we can kind of generally understand that it's trying to iterate a number over our message and our input, trying to get a value there, and it looks like it's trying to XOR that. You can see the symbol here with our iterator at a specific memory address. So we have some bit of memory that we're testing this with, and it's XORed with our input. So properties of XOR, right? We've got the greeting message that we're looking at, and our input, and some address in memory. So let's find this address in memory. There's got to be something there that we can retrieve. And that XORed with our greeting message should be what the input we need to supply. So we can figure out the quackme if we just XOR the greeting message and the memory at this location. Let's do it. Okay. Looks like we would display you're a winner if we get the flag there. So there's something peculiar. Let's see if we can go back to Hopper and then get this information out of there. Well, let's say greeting message. And where is that? That's got to be probably you've now entered the duck web. If we view this in Hopper, can you view it by trick? Yep, it's in main, and it's also noted as greeting message. So that is the string that we have here. And if we're going to actually use XOR, we can probably just go ahead and create a getFlag script in Python where we know we're going to XOR them. I'm going to use Pwn tools to XOR them. So let's use user bin environment Python. Let's say greeting message can equal that. Oh, let's use double quotes, and we don't need that \n. Let's use it as for real there. Let's import Pwn. If you don't have Pwn tools, you can just install it. Find online. I cover it in a ton of other videos, but it helps XOR things very, very easily in Python. So now we want to know where that memory address is. So back in our Sublime text, let's go ahead and steal that address so we can go to it in Hopper. So I've just copied and pasted it, and then I click Control G, or just simply G, and paste it in to go to that address. And you can see, oh, it's right here. So secret buffer, peculiar, right? Let's go ahead and copy all this. And I would go ahead and scrape out the ASCII, but note that some of it is noted as just a simple period. That's probably because it's not a printable character, even though that in hex it is something right there. So we do want that in hex handled. Let's go ahead and try and carve that out in Python. I'm actually just going to do sublime text 0x dot dot. So once I hit and select all those, let's do find all. Delete everything else, paste them. Oh, I'm sorry. So find all, Control X to cut them. Now they're all there. Now I've got them all. And then that 0x I'll replace with a \x, and then I'll replace all the new lines with emptiness. So now I've got a Python string that I can handle and use in Python. So let's say XOR string can equal that. And let's try and use pwn to print XOR greeting message and the XOR string. XOR them together. PicoCTF, quackme. We just got the flag. Awesome. Cool. So that was it. That's it. That's all we needed. Looks like that is the flag that we want here. Let's actually just import RE, and let's do re.findAll PicoCTF. Get our flag format set up, carve it out. And let's make that lazy so it doesn't get all of it. Great, there's our flag. Let's go ahead and submit that. And we've solved quackme, or an interesting crackme challenge. Normally when you see crackmes, the first kind of start of them, some of the simple ones will just try and do an XOR operation. But I hope that was kind of fun and kind of cool to literally take apart that like this function here, this do magic, and then just kind of change the name. Just follow through it and try and understand where it's going and how it's going there, why it's going there, what it's doing, and just changing these variables so they make a little bit more sense. And that's, I think, a good thing to do when you have a big, like a big function that is seemingly doing something interesting, like magic, as it says, and you could use that to figure out what's really going on. So, cool. Did I submit it already? I did. All right. So this is worth 200 points. It got mediocre solves, I think. Binary exploitation challenge. We've seen this before in PicoCTF 2017. It doesn't seem to be too difficult. It's just a matter of finding some proper shellcode. So if you don't know what shellcode is, you could simply Google it. But it is just kind of essentially machine code, right? Or like ops, Intel processor instructions, or compiled bytecode to do things, to actually make a program like actually do something else that it wasn't intended to do, like properly give a shell. Usually that's why it's kind of called shellcode, but it can do other things, right? Just making it do something else. So this program executes any input you give it. Can you get a shell? You can find the program here in the source code on the shell server, blah blah blah. So you can download this stuff. I've got it downloaded here, and we can mark it as executable if we wanted to, and then we can actually check out the source code. So not really all that interesting, just we know that, okay, it's going to go ahead and execute whatever we give it in a buffer, like as if it were code, as if it were like compiled instructions. So let's try and see if we can track down shellcode. We want to get a shell, right? So a resource that I use for this is shellstorm.org, and their shellcode actually has just a page for a lot of interesting stuff. And let's say we're working on Intel x86, right? But we are working on Linux. So let's find something that will execute bin bash or bin sh, or whatever the case may be, something that will actually go ahead and give us a shell. There are a lot of options here. I like to have something that uses tacp, so it keeps privileges just fine. And let's look for that. Let's just look for tacp. Bin bash, bin sh, tacp. That one will probably work. Yeah. Oh, exec ve bin bash bin. That one's perfect. 33 bytes. So what we care about is this hex, right? The actual machine instructions and opcodes and assembly. So let's go ahead and paste those in to Sublime Text. I'm going to cut up those new line characters and quotes, and all the spaces as well. So that way we just have that in Python. And then what I will do is I will have Python print that out. So I'll use print, paste it in here, and then that's essentially running bin bash. Let's go ahead and give that to the vuln function, and it says thanks, executing now, but it closes right away. So why is that happening? Well, we aren't capturing kind of the input that bash or the shell is waiting to receive. So what we can do is we can actually execute our payload, and then immediately following it, So I'm going to wrap these in parentheses, right? These commands here. Immediately following the execution of our payload, we'll open up cat, or we'll run cat. So standard input will remain open, and that stuff will actually go to the bash shell. So I can run ls, I can run who am I, and you can see we're getting our commands back. So now this is happening on our local box. We want to be able to see how we can get it on the shell server. So what we'll do is go ahead and connect to it and move to that directory. I've got that ssh.script that I created earlier, so I can simply run that and log in. I might have mistyped my password. Yep, I did. I'm sorry. I fail. I'm John Hammond, the fail whale. Let's change directory there, and let's copy and paste that payload that we have here. We've got vuln visible, and we can just run that payload. And now we're executing bash, run ls, see who I am. I'm still the user, but I have the privileges to now read that flag.txt file. And we've got the flag. So that's simple, right? We've kind of done that before in PicoCTF 2017. Just a matter of tracking down shellcode and knowing what will do what will actually kind of work for us. I've tried to use pwn tools before to generate some shellcode, but I never seem to get it right. I think there are some tricks and tips to actually make that happen and make it do the right thing. But when I just need to grab a shell and I don't have a huge limit at the amount of bytes I can put in, I just use Shellstorm because it's an awesome archive and a really good resource for a crap ton of shellcode. So. Challenge prompt here is to be successful on your mission, you must be able to read data represented in different ways, such as hexadecimal or binary. Can you get the flag from this program to prove you're ready? Connect with this command here. So I'm going to go ahead and connect to this, and it's kind of a long thing, right? If I just go ahead and go here, since we're going to start at the very beginning and make sure you understand how data is stored. Doctor? That's weird. If I input that? Oh, shoot, yeah. Okay. Sometimes I've noticed peculiar things in some of these services for PicoCTF where it will give the answer or like what it's expecting just kind of at the front of the service. So we will ignore that. That did correctly make that one right away. The next one is give me this information as hex, as a word, etc. So right now, see, we're given binary, and it wants it in as an ASCII word. Next we're given hex, and it wants it as an ASCII word, and we'll keep moving up from that. So let's just write a script to be able to do this, because it says, to make things interesting, you have 30 seconds. So it's trying to encourage some scripting. But now that we've actually interacted with the service, let's go ahead and work with it. Let's create a Python script. I'm going to call mine ape.py. That's an inside joke, by the way. I know a lot of people ask about it. They say, why do you call your scripts like ape? And I say it's because I just throw stuff at the wall and see what sticks. So let's use pwn tools. Let's go ahead and use pwn.remote with the host and the port being these. Host as a string, port as a number or an integer. So let's say S for our session or a connection or whatever, and let's close it once we're done with it. Let's try and do print s.receive. And we're going to start from the very beginning. Please give me the blah, blah, blah as a word. Let's try and cut that out with import re. So s.receive, let's say prompt can equal this. Let's print out the prompt. Let's say binary can equal prompt dot, well, we want to use re to find it out. So let's do re.findAll. The string as a word. Let's go prompt. Yep, that should be a second argument. So I need a parentheses closing that, calling that function, and let's print out what we get. What is binary? Okay, we get the binary just like that. So let's go 0 to carve that out. Let's go replace new line. I'm sorry, spaces, right? So now we have the binary, and then let's go ahead and say int. So incorporate that int as a base in decimal. So we say base 2 to understand that in binary, and then it converts it to decimal, base 10. Then we can go hex on that and carve out the 0x at the start. We'll just slice it off, and then we can decode that from hex to get it to ASCII or a word. So we would send that. So our answer can be that, and let's go ahead and s.sendLine answer and then we'll do the next one. We'll keep moving. Let's do s.receive. Check it out here. Oh, okay. Now enter that as a word. So we'll use the exact same thing. Let's call this one hex, hexadecimal. Let's print that out, see what we got here. And okay, we can just decode that one easily. Decode that to hex. And let's say that that is our answer, right? Do that again. Now let's get the next segment. It says, please give me all of this as a word. So this is interesting because this is octal, right? Like, you may not notice it. You may think it's just like ordinal values, but it's actually all less than 8 and all less than 7, right? So we can say that we're going to have this. Now octal, print octal. That's what we're working with. Okay, it carves it out just fine. Let's go ahead and remove all those spaces. And we'll say that is an integer base 8. Cool. So now we can mark that as hexadecimal. And now we can decode that. Once we slice it up, remove the 0x at the very start, and decode it from hex. Oh, I have an odd length string. Am I wrong here? Maybe I am. Let's try a different method with that. Maybe that's not octal. Maybe I'm wrong. I'm sorry, didn't mean to drag you guys down in a mistake. Let's see octal. Let's do some list comprehension here. Let's just say x in octal dot split for x in. So let's say x. Let's see. No. Should I have done that at base 7 or something? Oop. No. Oh, well, wait. No, it's because I'm an idiot. You can't concatenate all those things and put them together. They are different numbers on their own. So we do want to interpret all of these as octals. There we go. So now let's do character of the decimal number of the integer. Okay, and then we can put them together. So now we're getting a real word. Good. So answer. I'm sorry. That was stupid. I'm an idiot. It's fine. Let's do s.sendLine answer. Let's see what we got here. Move to the next one. Oh, sweet. We got the flag. Let's go ahead and print out the flag. Let's do... Actually, I don't even need that. Let's print re.findAll PicoCTF. Carve it out here. Prompt 0. Good. And then we don't need any of these other stuff now anymore. So we get a simple, clean pwn.context.level. Context level equals critical. So that way it won't show all those connection strings. We can only get the flag. Did I do that wrong? Maybe I did. Let's do from pwn import all. And let's just do remote. We don't need that. What's this? What the heck is going on? Is that because it's... Alright, well, I don't care. I tried to test it a little bit, but it doesn't really matter as long as we're still getting the flag just like that. So, interesting note here. The flag is just noted as delusions about... Oh, I gotta mark it as executable. My bad. The flag is delusions about finding values, and I think that's a callback to delusions of grandeur, which is a... Oh, jeez, I don't like that. That's stupid. I'm sorry. It's a callback to Delusions of Grandeur, which is one of the Air Force Academy CTF player names. So I mean that's a reference between Mr. Carlisle, who was working there and was originally an instructor at USAFA, U.S. Air Force Academy, and is now with PicoCTF and the Carnegie Mellon team. I think he's I don't know for sure. I may be wrong. I don't speak in his behalf, but I think he's working now at Carnegie Mellon, which is crazy cool. And a lot of the USAFA grads are actually some of the developers for PicoCTF, or have been some of the problem developers and the problem leads. And I know those guys, which is pretty cool. So hey, shout out to you. I love you guys. Hope to see you very, very soon. This challenge is called You Can't See Me for 200 points in the general skills category. It says reading transmission, you can't see me, transmission ended. Maybe something interesting lies in this location. So it's on the file server, right? It's on the shell server. So let's go ahead and connect to it. I'm just going to run my ssh.sh script. Go ahead and type in my password so I can log in. And let's change directory to that location. If I ls, there's nothing in the directory. So I figured, like, well, let's check out hidden files. Let's ls tac a. And you can see there is a period for the current directory, 2 periods for the parent directory, just as you always see in ls-tac-a, and those are noted in blue with ls colors because they're a folder, right? But we have an interesting thing where we have this other period file. So if I want to try and cat it out, I wouldn't be able to like cat period. It says, well, it's a directory. That doesn't work. Can I try and cat this directory here? No, it still considers it a directory. So weirdness, right? I can cat all. No, there's nothing here. Cat star.all or period.all. That works okay for me. That will be able to interpret stuff that is starting with a period. Another thing that I tried was like grep tac r with period. Period doesn't mean the file that we're looking for, but it means the pattern that we're looking for. And I'm using regular expressions, so it will match anything. And tac r means recursive, so all the files that you see, and that will receive it here. Note that it's a period and a couple spaces. So if I wanted to run like cat period //, then it will read it out because I needed a / space and / space to actually like interpret those spaces in there. I could cat dot space space and that would read it out, and you wouldn't need the period in the start because the space will work. But again, it has to be in quotes to denote that. So interesting thing, right? Anyway, we got the flag. Excuse me, I'm sorry. That challenge is complete. And we're good to move on. Mark that challenge as complete. Let's go ahead and paste it. Sweet. Next challenge is called buttons. It says there's a website running at this location. Try to see if you can push their buttons. So we have buttons. It says push me, I'm your only hope. It says you did it. Try the next button. Button 2. It says boom. Oh, whoa, I'm getting rickrolled. Holy crap. I can't show that. I'm going to get a copyright strike. It says form disabled. This incident has been logged and reported to dev null. So let's check out this page here. It says form action button2.php. It looks like there isn't anything here, but it is trying to post to button2.php. So let's see if we can actually just make that request, right? We can probably just take button2.php, take that URL, and run that curl command with it. Make directory buttons, cd buttons. Oh. Let's run curl and then tac x to specify the method. Post, and let's use the URL here. Awesome. It just pumps out the flag. Cool. Let's go ahead and reverse it so I can just cut tac D, get the very last field of spaces, and then reverse that back. We don't need all that output from curl, so that works just fine as our get flag script. Bin bash. Mark it as executable. Redirect that to a flag.txt file. Sweet. Copy to our clipboard. Clip, not cleop, and we can submit that. So awesome. Not too hard, right? Those are interesting challenges, kind of a cool trick, an interesting thing, but just kind of being observant and really looking at what you have in front of you, you'll be able to kind of piece it together and have that intuition to know what to do with it. So you could do this with curl, you could have done this with Python requests, you could do this with probably like developer tools if you wanted to, fire up some F12 in your browser. But hey, hope you guys enjoyed, hope you like watching these. This is a video write-up for the challenge Ext Super Magic from PicoCTF 2018. My name is John Hammond, and let's just dive right in. This challenge does not have a whole lot of solves, and I think it was kind of a really struggling point for a lot of people. It's in the forensics category. It says we salvaged a ruined Ext or Ext Super Magic 2 class mech recently and pulled the file system out of the black box. It looks a bit corrupted, but maybe there's something interesting in there. You can find it at this location on the shell server, and we have a download. So you can download it with wget. I've got it in my file system already. I've downloaded it already. And what do we do with this, right? Like, it's a forensics challenge, so we can run foremost on it. We can see if we've got anything in there. So JPEG, right? EOG, all these things, but there's nothing good or particularly visible here. You can try and make out some text, but all it's trying to tell you is that your flag is in another file. So this is a rabbit hole and a red herring. Just kind of sucks. Wasn't very good for us. So binwalk, right? Strings, or anything we could do to try and get some information out of this. Exif tool, nothing really good here. Flag.jpg, could I unzip this kind of thing? Like what? I didn't know what to do with it. So I checked the hints, right? You can do that. It's PicoCTF. That's cool. They say, are there any tools for diagnosing corrupted file systems? What do they say if you run them on this one? Sorry for my stutter. Getting all excited here. So this is FSCK, file system check, and we could run this on it, right? We could just simply run FSCK and try and tab autocomplete, but it would normally just try and want to run it on some of your devices. So if I tried to ls and were to give it simply this, it wouldn't want to work with it. I admittedly didn't know, like, okay, what do I supply here? I don't know anything about this thing. Do I need to give it a super block or a block size? I don't often use file system check. But I kind of noticed something in that this was ext4, FSCK file system 4. So I try to see, are there any other FSCKs that I could work with? FSCK.ext2. That seemed to be a thing. So maybe I could run that on ext super magic. It seemed to want to work with it, and it seemed okay. It read it just fine, but it told me everything that I kind of expected. Like, okay, it's corrupt, it's broken, there's something wrong. Bad magic number in super block invalid, bad magic number in super block. So this rings a bell, right? Knowing the challenge prompt, knowing what it is that we're actually working with here, called ext like super magic. Maybe ext has got to be the file system, super's got to be the super block, and magic number has to be the super block thing. I'd probably say 2 class because it's ext2. We could have tried ext3 or whatever we wanted on it, but I knew that one kind of rang a bell. Looks like both would work. Nice. But ext4 handles it just fine as well. Weirdness. So now we kind of have a little bit more of an objective. We know that the super block is kind of corrupt. It has a bad magic number. That's why if we were to run file on this, it won't tell us straight up, oh, it's an ext file system. It won't tell us what kind of file system it is or what kind of file it is. It just thinks it's data. So what I did from there was I tried to kind of Google and look around. I figured ext2 file system, super block magic number, as you could see in my history already. Super block magic number. And you can see some research that I did. I went straight to Stack Overflow, super user, whatever the case may be, and I read this article, where they said, okay, they had a corrupt file system. The magic number was broken. And they say the magic number is a sequence of bytes that's used in all files of certain formats, usually at a given position, typically at the beginning, that kind of note the signature or the fingerprint of that file. So when we're applying this to a file system format, for example, ext2, ext3, ext4 file system always has the bytes 0x53 and 0xEF at positions 1080 and 1081. So, good to know, right? Maybe that is something that's wrong. We can go ahead and check that out. If the file command were to run on it and it would be able to recognize the bit by those magic numbers, then it would properly tell us it's an ext file system. But since it didn't, maybe this is wrong. So let's go ahead and check it out. I don't know if hexedit will be particularly what we want to use right now, because we'll see the position just in hex. Yeah, that's no good. I want to go ahead and try and run this with like gex or something. Ext super magic. So now I have a specific one that I can go ahead and go to. So a GUI that I can use, and I can hit Control J or from the file menu to go to byte, and we want 1080 and 1081. So let's go to 1080, and now my cursor's there, but you can see that it is not 0x53 and EF, so let's change those. Let's do 0x53 and 0xEF. Great. Now I can save this, save buffered ext super magic image, and now if I go ahead and check this out, if I run file on that, it says it's a Linux file system. Okay, let's try and extract this, or not extract it, I'm sorry, but mount it now. I don't know if Foremost will actually work on it any better now. I don't think it will, but we can go ahead and mount it. Let's just create a mount point directory. Mount mount, sorry. Let's correct that just for good's sake. And we'll go ahead and mount this file at the mount point right here. And we will need to be root, so let's sudo that. Enter my password here, and now I have mount point. So let's cd there. See what we have. Wow, lots of stuff. Will flag.jpg actually open for me? It will. Can zoom in here. Interesting picture. Your flag is this, so let's take note of that. I didn't mean for that split. Let's move up in the directory, get it in the proper place, and let's run nano for flag.txt. Try and type out our flag. PicoCTF A7db29 ECF 7db 9960F 0A19 FGGE 9D00AF0. AF0. Yep. Okay. Again, your flag may be very different than mine because of PicoCTF's random generation. So keep that in mind. Did I type it right? I really freaking hope so. I think I did. Yeah. All right. Cool. So that was that. I struggled on that challenge for a long time, and I think a lot of people did. Like, don't hesitate. Like, don't be ashamed. No worries if you did. Look at how many people solved this challenge. So, it took a lot of time, right? But that's the point of a capture the flag. You bang your head against the wall over and over and over again. Just you don't give up. You keep trying. Offensive Security's logo, and eventually you'll track something down. Research is good. Finding different tools are good. Just trying to figure out what you can do to examine this from many different angles and many different perspectives until you get something. So let's mark that challenge as complete. We did it. This challenge is called The Vault for 250 points in the web exploitation category. It says there's a website running at this location, and here's a link. Try and see if you can log in. So we can view the website. It has a simple login page, and it actually gives us some source code, so we can check that out. Looks like it is running PHP, displaying errors, and error reporting is on, includes the configuration file and some database that it's trying to open up. It actually reads in our username and password, also a debug variable that we can specify, and then it actually tries to use a query with select one from users where name is equal to something and password is equal to blah, blah, blah. Okay, so we have potential SQL injection, right? Like, it's just concatenating in, or at least placing in our variables. It's actually not doing anything to sanitize them in the query. However, when it's displaying them with the debug value, it will actually just go ahead and display the special characters with it. So it tries to like HTML entitize it as necessary. So we won't particularly need this because I think we're smart enough to know, well, we know our SQL injection vulnerability. Let's totally take advantage of it. They do something interesting here, though, because they have a validation check. They try and use some regular expressions to determine if we're using an OR syntax. So, like we're used to a SQL injection where OR 1 equals 1. Looks like they'll test if we actually see that. If we see that pattern at all in the username, or interestingly enough, the password match is still running in the username field. So we could determine, well, password is going to be equal to, we can actually inject in there, but we can't in the username. Peculiar thing. And if the user match and password match is not equal to 1, if it actually returns some location in the preg match, it will determine we detected SQL injection. So, peculiar. Interesting note, though, that it's not testing it in the password. So, let's go ahead and see what we can do. We would try our regular SQL injection, or 1 equals 1, comment, and SQLi detected. But let's change this. We could say anything for our username, and try or 1 equals 1 on the password. We log in. That works just fine for us. Another interesting thing is just selecting anything from, let's say, probably the users, right? We know there's very likely going to be a admin user. So if we had just had that username and then commented out the rest of the query, we could log in just like that. So I don't know if it actually has anything not in there. Okay, so no, we have to have an admin account. was worth trying, was worth figuring out. But those are the two easy ways to win that I saw. You can use the OR syntax in the password field because it's not testing that, or you could use it in the username. Just go ahead and use the admin and query out or comment out the rest of the query. So now that we have the flag, we can go ahead and submit. But let's write a simple get flag script for this. It looks like it's just pasting this. I'm sorry, wow, posting this to login.php. So let's go ahead and make a little curl thing for that. Not too hard, right? We can use curl this location. Let's say tactec data username can equal, let's say admin hyphen hyphen, and it gives us the flag just like that. So grep tacoe. Wow, caps lock. What are you doing? You're not welcome here. Get out of my house. Color equals none, and make curl silent. Great. There is our simple one-liner. Awesome get flag script. Just encapsulating our answers, that's all. Save it to flag.txt, throw it in our clipboard, and we can submit it. The next challenge is called What's My Name for 250 points and is in the forensics category. It says say my name, and we can download this file. So I've actually got this already moving. Got it downloaded already. And it is a PCAP file. So if I go ahead to What's My Name, we have myname.pcap, which is a TCP dump capture file. We can open this thing up in Wireshark and explore it just like you would with any, actual PCAP. But there's a lot in here. And it's doing some DNS stuff, I'm assuming. That's probably why it's trying to get a hold of the what's my name thing and the name server of an IP address or whatever the case may be. I didn't care to look through this because all I did was a simple, please let me out of Wireshark, dude. Let me out of Wireshark. What are you doing? All right, fine. I just ran strings on this, right? Pretty easy. And usual technique, usual little weapon that we go for here. Look for our flag format, carve it out, and if we find it, we win. So just like that. Not a hard challenge. Just kind of knowing. Let's go for the quick cut corners thing. Make a simple get flag script for that. Flag.txt and xclip. Go ahead, submit, and we're cruising. This challenge is called Absolutely Relative. It's in the General Skills category. It says, in a file system, everything is relative. Can you find a way to get a flag from this program? You can find it here on the shell server, and we have the source. So this is something that is necessary to run on the shell server, so I'm just going to go ahead and connect to it there. But I do want actually the source code so we can check out what it's doing. Let's wget this, and let's open it up. All right, so character yes should be just simply yes as a constant. Yes length should be 3. Interesting. We have a main function that will read the flag and create a buffer for it for permission, etc. It'll open up the absolute path to problems, that location, and flag.txt. So flag.txt will open up an absolute location. That works here. It'll go ahead and read it and open it up. But the permission file is actually relative. It's doing it from the current directory. So that's peculiar and something to note. If file, it'll read through the permissions and actually determine information out of it. Just read it. And if the string compare permission is yes and yes, so if the length of yes, if we've actually read the permission.txt file to say the word yes, it'll say you have right permissions and it'll give you the flag. If you do not have specific permissions or the sufficient permissions, it will not give you the flag. So because permission.txt is read out of a relative location, we can control it. And let's go do that. Cool thing here. Let's go ahead and jump in. We have the location on the shell server that we want to connect to. So I'm going to .ssh over there. I'm just using my script that just enters the command for me. in with my username, so I can simply enter my password and jump in. And we have the flag.txt, the absolutely relative file, absolutely relative.c, etc. So we can't view flag.txt. Can we view permission.txt? Oh, we don't even have it. Weird. You do not have specific permissions or the sufficient permissions to view this flag. We can't create a permissions.txt, can we? Nope. Permission denied. I don't have the permission to do this there. I could try and write yes, but it won't let me save the file. So we can now move to some place where we do have write permission, like the temp directory. Let's try and temp jh YouTube, and let's go there. Temp jh YouTube. Great. Now let's go ahead and create a symbolic link. And I've done this a lot in some Bandit or Leviathan or some over-the-wire war games where I create a symbolic link to the absolute file here, the program that we're trying to run in its absolute location. Let's get the absolutely relative program in this directory. So now I have a special kind of blue, an absolutely relative file that is in this current directory, but is a symbolic link or kind of like a shortcut to that real absolute location of the program. So now I can create a permissions.txt and I can have it say yes, just fine. Now if I run absolutely relative, it says you have write permissions because it's trying to read the permission.txt in the current directory that I am in. So I can create the permission.txt file, it'll read it just fine, and it'll give me the flag because of how we read the source code. So that's that, right? Pretty simple, pretty cool. We can go ahead and mark that as the flag and say that this challenge is complete. Let's go ahead and submit it. And that's just a neat thing. Symbolic links are very, very cool. And when you have control over a shell server or you have a location where you can have your own files and have your own space, it's really neat. So the challenge prompt here is, what does ASM2 with these arguments return? Submit the flag as a hexadecimal value, etc. We've kind of seen this thing before. So we're given some source code. Let's go ahead and copy it, download it, and I'll just wget it into the current directory here. Looks like we have it there. I'm going to open it up in Sublime Text. I'll zoom in a little bit so you can see this. And I'm going to change the syntax highlighting to assembly. So what I'm going to do is actually create a new script that will kind of recreate this in Python. So let's do like recreation.py or something, or whatever we particularly want. I use the file header plugin for Sublime Text to get that boilerplate stuff at the very top there. But okay, what we do is analyzing the assembly. Let's say this is function prologue. I'll keep zooming out, hopefully you can still see. Function prologue, and then we set EAX to the second argument, 0xc, right? Because EBP plus 4 on the stack is just going to be our return address, I believe. EBP plus 0x8 will be the first argument, 0x plus xc is the second argument. Again, incrementing by 4 because that's the size of the data type there. Let's just include this as a comment so we know that EAX will equal the second argument, 0x21. So let's say Python can do that as well. And let's do the next line where we're setting EBP minus 0x4. So a local variable set to EAX, which we know to be 0x21 still. And let's just say that can be EAX in the Python code. We'll do the same for the next argument. So EAX can equal just the first argument we give it, 0x8. And just using, not using this because that's the same value here, but using it because it's the first argument that we're passing this function. EBP, or the base pointer, plus 0x8. So once we set EAX, we'll do the exact same thing just as we did previously with a new local variable. We can say EBP minus 0.8 will be able to equal 0x8 in this case. And we'll do that just as we did earlier in Python. Set it equal to EAX, but before we do that, we have to set EAX to equal this. So that's just creating these local variables for us in our stack, or from the stack in the very start of the function. And then we jump to part B. So go to part B. So part B, what it's doing is it's testing, has a compare statement here, or compare instruction, and less than or equal to. So let's do if EBP plus 0x8, so our argument here, we actually don't have a variable for that yet, so let's go ahead and create one, because underscores are going to be minus in this case. Let's do minus here, and minus. So now we can have EBP minus, or plus, sorry, for arguments. That can go ahead and equal the first argument that we give it, second argument that we give it, 21. And in fact, we could have just be setting these here rather than using the hard-coded values. Okay, so now let's test if EBP plus 0x8 is less than or equal to this value. If it is, we are jumping to part A. Otherwise, we are setting EAX to equal EBP minus 0x4, and then we will just print out EAX to see what it is we actually need here. Because that's the end of the function, right? There's our function epilogue down at the very bottom. Okay, so part A we need to actually look at now. What it's doing is it's setting EBP minus 0x4, so that local variable, and it's adding 1 to it, so plus equals. So part A will take EBP minus 0x4 plus equals 1, and then EBP plus 0x8 will also be added with a 0xa9. So it's just incrementing. It looks like it's trying to do some kind of loop, looks like it's trying to do some kind of division, I think, because it's testing, okay, whether it's a factor this however many times, blah, blah, blah. But since our Python code should be able to handle it just fine, let's go ahead and run it after we set EBP plus 0x8 plus equals 0xa9. So when I run this, we get 8. Okay. Let's see what we look like here. Is EBP correctly being set here? Looks like if we try and debug this here, no, it's not. So something is wrong in our code. Let's check out what EBP minus 0x4 is. 33. And that should be 0x21, so that works just fine for us. Now we do the same thing with minus 0x8 for local variable. And that's 8, just as we would expect. So now we're checking if EBP plus 0x8, which we know is 8, is less than or equal to this thing. So let's print in loop. Okay, that only happens once, so that must be why. Oh, of course, it has to go back to part B once part A is done. We just didn't have that procedural loop in there. So we can do a while one here. Actually, just to loop it, because we know that that's just going to return back to that other part B test. So once we print EAX, or once we actually have that else be returned true, let's print EAX and then return. So now we'll break, actually, because we're not inside of a function, so we'll stop looping. So we have 120 as our final answer. Okay, let's see what that is in hex. Run this, 0x78. Perfect. Sounds like a plausible answer. Let's go ahead and submit it. And we got it right. Okay, cool. So all that we really did there was recreated this assembly code in Python, so it's something we can easily kind of understand and manage. We stepped through it just with our comments on the side, and we just try to recreate something that we can run very easily. Maybe we could do this with NASM if you just wanted to compile it and run it. If you are that much of an assembly guy, sweet, more power to you. But I just figured, okay, I'll step through it and try to understand it a little bit. The while one thing, or the loop, is interesting. Remember, because we immediately jump to part B, and then if it's less than or equal to A, which for the first couple iterations we know it is, it'll move up here, and then after it runs through each of these commands, it continues back into part B, because it's assembly is spaghetti code, right? So you just dial back into it. Okay. This is a video write-up for the challenge Buffer Overflow 2 in the binary exploitation category. The challenge prompt here is, alright, this time you'll need to control some arguments. Can you get the flag from this program? You can find it here on the shell server, and you have the source code given. So let's go ahead and download these things. I've got a directory all set up for it. We just got to work with it here. We are given the source code, so that will be super duper handy for us. We don't have to worry about trying to reverse engineer a ton. We are given the code. So let's open it up in Sublime Text. Okay, we have, let's see, some includes here a defined definition for the buffer size and the flag size. This just must be the length of either the string or the buffer that we're working with. The win function looks like it simply opens the flag, determines whether or not it's actually there. You do want to be running it on the shell server. Okay, so maybe we'll have to create a fake flag if we're testing locally. And it needs to actually have the arguments of dead beef and dead code. Okay, just in hex. We will need to input those in, let's see, like little endian, right? Because the binary needs to be able to read and process it in its own language or what it's used to. But if those aren't supplied, it won't give us the flag. Buff is where the flag is going to be read into, so the only way for us to see the flag is whether or not we can get those arguments set up correctly. This shouldn't be too much of a challenge for us. We have a vulnerable function here running with a buffer size and a buffer here that it's just reading with the gets function, and we know that gets is very, very dangerous. If you haven't seen that before, just check out the man page for gets. It should tell you never ever use gets, because it does not determine the end of the string. It does not actually check the boundaries as to whether or not you are overflowing a buffer. So that's the vulnerability we can take advantage of. We inherit the next user's we inherit the set UID user's permissions, so we can actually read the flag file probably once we log into the shell server, and then it asks us enter a string, and it gives us the vulnerable function. So let's try and run this, see if we can work with the binary. Let's make it executable. It should tell us anything. If we try to buffer overflow it, maybe it's trying to... Oh, we need to actually jump to this win function, right? We want to be able to buffer overflow there. So let's try and make that happen. We'll use Python taxc print a like 100 times to go ahead and get a lot of output, and we can just give that to the vulnerable function. We want to find where this buffer overflow is, so let's give it a couple more until we get a seg fault. Let's go 8 times. There's a seg fault. Let's check out the very end of dmessage to see where we are overflowing. And nothing useful there, so let's go a little bit more. Let's go 12 in. And again, I'm using increments by 4 here. General protection, etc., etc. Okay, let's see what 16 gives us. Okay, now we have a seg fault at a given address that is all A's, or 41414141 in hex, right? Because that's what a capital A is in hex. So we know that following 12, we can go ahead and get any address that we want to jump to. So if we were to give it the address of that win function, that would allow us to jump to that function. So let's try and do that. Let's go ahead and actually find the address of the win function. I'm going to use readelf tac s to see the symbols here on the binary. I see win right here, and this is the information for it. Okay, I'm going to use another window down here so I can use Python, and then I'll import the pwn library. Okay, and then I'll pwn p32 on the hex value of this. So that function, just in itself, you may have seen me use it before. If not, all it's doing is converting it to little endian as a simple string for us. You can do the same with a built-in library if you don't have pwntools installed, although I totally recommend it. Pwntools is awesome. You can import struct and then struct.pack with a special formatter, the less than sign for little endian and capital I for an integer, and then you could again give it the hexadecimal value that you want. I'll paste that in there and it gives me the exact same output. Okay, so let's go ahead and use this now in our payload. Going back to the top window here, you can see I'm going to, instead of entering a lot of B's, I'll put in this hexadecimal value or little endian format for the win function. Now we're running the win function. It tells me the flag file is missing. problem is misconfigured, and that's good. That way we know, okay, we are in fact running the win function according to the source code. Let's create a fake flag that we can work with just locally. Let's say, John, please subscribe. Cool. So now let's go ahead and run this. And segfault, score dumped, and are we jumping to the win function? Seem to be, but just returning. Okay, that works fine for us. Let's see if we can get these arguments in here. Where are we going to return to after this? Well, right now, our program doesn't know. Remember, on the stack, when you get to EBP, or the base pointer, +4 is the return address when we're building a new stack frame, right? So the following 4 bytes should be a return address. Let's go CCC so you understand a little bit more. It's not the same example. Now when I run this, we get a segfault. If I demessage tailed this, now we're going to 43434343. So we would normally jump to this function because we have not supplied the arguments and our function is just going to return. Now we want to go ahead and supply these arguments, right? We need arg1 and arg2. We're given the values that we need here, and they're just in hex, so that works just fine for us. We can use the same thing with Python to go ahead and convert these to little endian. I'll paste them in here. Now we have dead beef as a string that we want. I'll concatenate that into our payload here, and then we'll do the same thing for dead code. We can go ahead and convert that to little endian, just doing it in Python. Got the string that we need, and we will tack that onto our payload. Great, now when we run this, I get the flag. And we're still getting a segmentation fault, that's fine, but we're running enough of the code that we need to. So now that we have our payload, let's go ahead and redirect that into payload.text. And I suppose we can actually just copy this because we're going to need it once we're on the shell server. So let's go ahead and connect to it, ssh.sh to log in. See if I can remember my password here. Sweet, we're right. I'm going to paste this down below so I have it because I need to copy and paste this location on the shell server. So we can quick and easy just change directory there. Great. Now I'm in that directory and we would be able to read the real flag.txt. Obviously we can't just straight up read it because we don't have that user's privileges, and that's why it has that set GSID and all that other crap in the main function, so we can inherit their privileges and permissions. So since we have our payload, let's go ahead and copy that. Let's echo that out. So there it is. And now let's pipe it into the vulnerable binary. And we're given the flag, just like that. I know it looks a little bit of a mess here, but you can see it. PicoCTF addresses are easy and some hex bytes. So just like that, we have our flag. All right, let's go ahead and submit this. I hope that made a little bit of sense. It's everything that you already know, right? From watching the other videos, you know that above the stack frame, right, the base pointer, +4, the bytes following the address of where you're going or where you're jumping on the function here, is your return address, which we can set to be anything or garbage, right? And then you have the arguments that follow. So arg1, dead beef, and then arg2, dead code, we're just supplying again in the endian because we need it in the format that the binary can read and understand. So cool. Let's go ahead and make that the flag file. No longer the please subscribe, but please do that. That'd be awesome. Join our Discord server, and we can mark that challenge as complete. Another one done. This is the Caesar Cipher 2 challenge. It says, can you help us decrypt this message? We believe it's a form of a Caesar cipher. You can find the ciphertext also at this location on the shell server. We're given a download, so we can go ahead and just simply download that. I've got a directory created for us to work in. You should do the same. And we're just given simple ASCII text. So let's check out what that file is. And it's a lot of characters. So normally when we see a Caesar cipher, and you can Google it if you haven't heard of it before, but it's a pretty simple and very common form of classic cryptography or whatever baby stuff. So normally you'd expect to see it all in the range of regular English letters, like A to Z, 26 letters in the alphabet, stuff like that. In this case, we're working with some punctuation, right? We've got underscores and colons and braces and crap like that, so we know something is up. We can still work with this, right? Because we understand the ASCII table, or the range of characters that we could possibly work with on our computer. So let's create a simple ape.py or a Python script to work with it. I call it ape because I'm just throwing stuff at stuff and seeing what works. So I'm going to use a context manager because people yell at me until I use them. It says with open ciphertext, the name of the file, as handle. We can say handle.read will actually be our content, or what we're actually working with. Now, let's go ahead and loop through all of the possible permutations for this Caesar cipher, right? We know not just 26 letters, we're essentially brute forcing, right? What could the possible key be? It's a small brute force space, right? Because it's normally 26 for a regular Caesar cipher, but for this upgraded level, we know we've just got the 255 characters that are part of the ASCII table. So let's go ahead and do that. Let's say for I in range 255, because that's how many are in the ASCII table. And if you don't know what I'm saying when I'm talking about the ASCII table, you are given a notion of it in the hints if you want to go ahead and check that out. This is what we're looking at and working with. So just characters represented as a character, also in hex, decimal, etc. But there are 255. So let's go ahead and continue our script. For I in range 255, we can create a new string, or just to hold the string that we're going to be working with, the new one that we generate once we've done the Caesar cipher operation to it. And then we'll actually go ahead and loop through the characters that are inside of our ciphertext. So for C in content, C being character, right, what we can do is we can do new string.append. And what I'm going to do is I'm going to take the character rendition, or CHR, of the ordinal value of the current character that I'm looking at, so that will convert it to the number on the ASCII table, and then I will add on an I, so the current index or iterator that we're looking at in our 255 loop here, and so that's doing the shift. That's doing the actual Caesar cipher operation. But we've got to put it back in the range of 255 in case it goes greater than that. So we can do that by simply wrapping around, right, using the modulus operator. So that should simply work for us. We want to do that inside of our character string here, our character function here. So make sure that 255 wrap is inside the CHR function. And then we will close that append syntax. So, cool. Now, at the very, very end, we can print out the joined version of our new string. And let's go ahead and see what this gives us. If I go ahead and run python ape.py, there's a lot of garbage, right? Because we're going to get a lot of those non-printable characters that are still present in the ASCII table. If you want to clear this up, what we can do is, if my terminal will ever come back, okay, I think I broke it, whatever, YouTube Pico, let's get to Caesar Cipher 2, zoom in a little bit more. Let's actually run our ape script, but pipe it to strings, right? So now we have all of the printable strings that we could work with here. And we can be pretty confident, also because we can see it right there, that we have the flag by grepping for Pico, right? Or PicoCTF. And then we just have the flag here. Caesar ciphers just aren't secure. So, kind of neat, kind of cool, right? We can modify our script. We can say if Pico is actually in this, Pico is in the string that we're given here, we can print it out. And let's not do this twice, so let's just say new string can equal that after we're done looping. So we can print new string and just put it in that conditional. Now when we run python ape, all we get is our flag, so we can change this to a get flag script instead, right? Because I like to consolidate our answers, mark it executable, and then we're good. Redirect it to a flag.txt file. Let's throw it in our clipboard so we can go ahead and submit it. And done. 250 points up more on the scoreboard. We can mark this challenge as complete. And that is that. Simple Caesar cipher, but just expanding our search, not just using the 26 characters you'd expect in the alphabet, but going through the full range of printable characters or data that we can work with. What's going on, YouTube? This is another CTF challenge video write-up for the challenge Got to Learn libc from PicoCTF 2018. So it says this program gives you the address of some system calls. Can you get a shell? You can find the problem here on the shell server, and we're given the source code as well. So let's go ahead and wget these things. I've just created a directory for us to work in. and we can download the program and the source. So let's take a look at the source code, see what we're working with here. Looks like we have some regular includes, some definitions for the buffer size and flag size. We have a useful string, bin sh, so just a shell command that you'd see on Linux, not bash, but still a shell. And it says maybe this can be used to spawn a shell. Okay, cool, that is going to be useful for us. We have a vulnerable function here, reads in a buffer. Supposedly it says enter a string, and then it does not check the boundaries on our buffer. So we can go through with a buffer overflow attack, an exploit here. It says thanks, exiting now, and then that's about it. Okay, the main function sets our privileges to the next user, or whoever actually owns this on the shell server. It says this prevents binsh from dropping the privileges. Okay, handy, because that means we will end up wanting to spawn a shell with this. And then it gives us some useful addresses. It gives us the address for puts, flush, read, write, and the useful string. And then it lets us run the vulnerable function. Okay, so let's take a look at what we really have when we run the binary here. Let's mark this as executable and try and run it. It says here are some useful addresses, puts, 0xf7, dc, etc., etc. Same thing for all of these. They're all teamed to be in the same kind of format, and we can say with that f7, that is very likely on the stack, or the location of the function kind of in memory as we're running the program. It also gives us the useful string, which is probably just going to be, I'm probably wrong about this, it's not the .data or the .bss section, it's one of those, but that will remain constant. That should not change. And I think if we run this again and again, maybe ASLR is not on, or I'm wrong about how I'm finding these addresses or why they do not change, but they do not, thankfully, for us in this case. So what we can use and what we can take advantage of is actually some, oh, it looks like the useful string address changes. Maybe that's being sorted at a different location each time. That's fine. Still something we can pull out because we're running the binary. So what we do want to be able to do is actually use a return to libc attack. And you can look this up online and find plenty of guides that do a much better job of explaining it than I do. But if you want to see it happen, this is how we can go about doing it here. So because we're given some of the addresses here, normally you'd be able to find these in like a memory leak or some corruption in the program that will allow us to find these memory addresses. We can determine the address of system, or like the C function system that will run a system command. And we're, in the case that we want, run binsh, or our useful string, to spawn a shell. So since we can figure this out by determining just an offset between one of these functions that is part of libc and the function, the offset or the address for system in libc, we can calculate where it really is when this binary runs, or when we run the program. So maybe that doesn't make sense right now, but let's walk through it and do it for real. I'm going to open up the vulnerable program in GDB, and we could want to just examine puts, right? Puts can be the function that we want to choose to actually determine where system is in the program's memory. It's not going to give me anything yet because it hasn't ran the program, so if I just hit like run, we could break it main or something if we ever wanted to, just in fact, let's do that. Bmain, hit run, and now that we've broken, we have all of the functions still initialized, so I can just simply x puts, and it's at that location, right? Okay, let's just take note of this. I'll let's subl an ape.py. Get something moving here. Let's create a script, user bin environment Python, and let's say gdb puts can equal that. And now let's go ahead and find the location of system. So that's at this address. Okay, so now we can find gdb system. Great. So let's determine the offset, right? We'll say offset will equal a gdb puts minus gdb system. And now this offset, we can apply that with just using simple math, right? To go ahead and determine where that real system function is when we run the binary, because we're seeing that leaked address for puts, or whatever any of these system calls that we particularly want when we're running the program. So now let's go ahead and run the program, right? Let's clear out some of these and just work on our script here. I'm going to use pwn tools because it's awesome. So let's say elf can equal elf, or pwn.elf of /vuln. So if I were to look at it, now I have the binary that I can handle and work with. Cool. So what I could do is now determine a process for it. So let's do elf.process. That will just be p. So it will run the binary just fine for us. If I run Python ape, it's going to start and stop the process. Let's go ahead and work with it. Let's do print p.receive. And it tells us, okay, here are some useful addresses. Let's call this prompt so we can go ahead and work with it. And let's print out prompt, right? And now let's carve out the information that we want. Let's use regular expressions, and let's do re.findAll, because I think that's pretty nice, good hack. re.findAll puts location with our prompt. And let's see what we got here. Okay, it is finding the address just fine for us. Great. Let's say puts address, or we can just call it puts, that's fine. And let's say bin bash, let's find the location of the useful string. We'll just carve that out so we can print puts, make sure we get that just fine, and print bin bash, make sure we get that just fine, or bin sh, whatever. Great, okay, it carved them out just fine. So now we can determine an offset that we've already calculated, right? We can use the offset to determine the real location of system by simply saying system can equal the puts location that we're getting. Let's go ahead and convert that from hex, right? Because that is int 16. Because that's giving it to us as a string. We want to take it as an actual number. And let's go ahead and subtract the offset. So now I got system, and let's print out the hex of that to see if it's a pretty good candidate, right, for where system could really be in the binary. Looks like it works just fine for us. Okay, so now that we know the location of system, we can use that buffer overflow attack and technique to go ahead and exploit this binary and call system and run bin bash, get a shell. So let's do that. We want to overflow this. Let's test in the command line. Let's go ahead and do Python taxi print. What's the buffer here? 148. Okay, let's crank that. Let's do a times maybe 156 or 140. Thinking about numbers here. 52, 56, yeah. Let's go 160. See what we cover. Crank that into vuln. No segfault. Let's go 64. Jeez, what about 80? What? Does it not? Let's go 200. Am I even echoing this correctly? No, I'm not. Oh, I'm an idiot. I'm sorry. Okay, that's totally my fault. I'm sorry. Now we should totally get a segfault. Alright, sweet. 160. Let's check out dmessage now. Okay, 4141. Let's do 156, and then add in BBBB. Determine that is the... Okay, great. That is the offset. So we want now our payload to equal a times 156, and then we want the address of the function that we want to go ahead and jump to, right? So we need that in little endian, and that's why we have pwn installed, or pwn tools. So we can use p32 of system, payload plus equals pwn32 of system. We need a return address following that, right? So that can be junk, 4 letters, because that's just the size that we need. And then we can use payload plus equals that useful string. But remember, it's got to be in little endian. So bin bash, or I suppose bin sh is the proper name. Great. So now we've got our payload. Okay, let's go ahead and send this to the program, right? Let's do p.sendLine payload, and then let's make it interactive now that we've actually sent the payload and exploited it, supposedly. So let's go p interactive. That sounds really funny to say. Let's go p interactive. All right, we can run our script, and okay, broke something. Cannot convert argument to integer. What? Oh, bin sh is still int 16. Let's do the same thing for puts. So we convert it as a real number and not a string. We won't need to do that in our system calculation anymore. We don't need the system printed anymore either. So now we run this, fingers crossed, still have an issue. What is the problem? System. Oh, goodness. Puts. I had a typo. Okay, thanks, exiting now. And nothing. Is that the right offset? We were doing... Oh, what the heck? I don't know what I'm thinking there. 424242. 156 should be the address that we want. But that may not be IP. Yeah, okay. So I didn't fill up the instruction pointer. I always do that. I always misread this portion when I should really be looking at the instruction pointer that follows. So let's change this to 60, and let's see how that works. Maybe, hopefully, please. Run our ape script. Okay, cool. We don't get an end of file. I can ls, and we have a shell. All right, so we are successfully running shell, or binsh. So now we can use the same attack script in our actual, like, on the shell server, right? Do it for real. So let's .ssh, get over there, enter my password, and let's jump to that location. And one awesome thing about PicoCTF, like props to them, is that they, can I write in here? Attack.sh or .py? I don't have permission. Okay. Let's make a home directory thing. Oh boy. Make directory John. Sweet. CD John. Okay. Let's copy all of those things into here. Can I do that? Nope. Don't have flag. Okay. Let's create a symbolic link. ln-tech-s, this thing, flag.text into this directory. Okay, cool. So I can't read it still, but I can work with vuln and vulnc and everything. So let's create our attack.py in a file now that we have permission to write in, and let's go ahead and paste all this information in. So awesome thing about PicoCTF is that they actually have all of these like attack tools and stuff that we want. I think Radar 2 is actually installed on this. Nope, guess not. but Pwn tools is certainly installed, and we can use those on the shell server. So let's go ahead and run Python attack. It starts our program, and we fail. Why is that? Maybe we can run GDB and change these variables. Maybe it's just the shell server specifically. Let's try and run GDB vuln, run it, and then let's X system. Take note of this. And X puts. Take note of this. Now let's modify our script to use these values, which is the same, but system is different. Huh. Peculiar. Okay. Now let's see how we do. Python attack. Sweet. We have a shell. Let's check out flag.text. Still no. What? Oh, you know what? Maybe I'm an idiot. I have suddenly retained all of these permissions, and that's not cool. Let's change our attack script once again to not just use our binary and the one in our directory as the real program that we're trying to run, but instead use the one at that location. So nanoattack.py, and then rather than using pwn.elf at vuln in the current directory, let's do it at the real problem. So now, fingers crossed. All right. Can I now read flag.text? Yes, I can. Awesome. That was cool. I hope you liked that one. I hope you learned a lot. Hopefully I didn't breeze through it too much, or I didn't go into too many weird tangents or say too many stupid things that it totally derailed what you were trying to learn. But that is the attack for a return to libc like mitigate technique, right? You can, if you have a memory leak, or if you can find the address of some function in the binary while the binary is running, you can calculate where system is going to be in libc. And then you can go ahead and run system with some strings you can probably dig out or carve out of the binary. In this case, Pico is very nice to us, and they just straight up gave us a string for bin sh. And awesome. Now you've got a shell, because you can call system if you've got an attack where you can control EIP, or the instruction pointer. Call system, give it the argument to run a shell command, run bash maybe, and then you've got a compromised system in a cool case. So let's take note of this. Flag.text for real. There it is. Let's go ahead and submit it. 250 points. Not a whole lot of solves. So some good learning. Some good learning that we just did there. Let's move that to a completed challenge, and we are done. This challenge is called RSA Madlibs in the cryptography category. It says, we ran into some weird puzzles we think may mean something. Can you help me solve one? Connect with this netcat command, which we can copy and paste, and I'll go ahead and start to work with in our terminal here. So, looks like it gives us some information, a strange hexadecimal number. Hello, welcome to RSA Madlibs. Keeping young children entertained since well never. Tell us how to fill in the blanks, or it's even possible to do so. Everything input and output is decimal, not hex. So we're given a Madlib with Q and P, and we're going to need the following N. Is this possible, yes or no? So I've done a lot of RSA stuff before, but let's just kind of get the RSA Wikipedia page up and with us. So if you wanted to follow along, you kind of could if you haven't seen this before. So it is a method of cryptography, but it's really just a lot of math and equations. So for key generation, it actually ends up using with keys P and Q, and those are distinct prime numbers. N is in fact P times Q, so in this case we can just simply multiply them. What I'm going to do is actually go ahead and create a script for this. Let's do ape.py, and I'll put it down here. So let's go ahead and user bin environment Python. Let's get pwn, because I'm going to use that to go ahead and connect to this stuff. We can go ahead and connect, or at least just copy and paste this stuff here. So I'll have the host that I'm trying to connect to, and the port visible here. Save these as variables, so I can go ahead and connect to them. Let's do s equals pwn dot remote, host and port, and then let's do s dot close, just to be good and stuff. Python ape. Cool, it'll connect to it or not. Let's do our testing in the terminal, and then let's just use the script and the Python stuff to actually keep track of our answers. Because if you notice, if I keep connecting back to this, the numbers that we're given do not change. They stay static. Another interesting thing is that this hex that they give us is actually very, very strange, right? I went ahead and copied this. What I'm going to do is I'm going to decode this from hex, and it is, in fact, the flag, just at the very, very start of the service, which is strange. Maybe that's intended, maybe that's not intended. I would assume the latter, but for the sake of learning, for the sake of education and stuff, I'm going to go through the rest of this challenge anyway. But if you just wanted to be a cheapskate, go ahead and submit the flag. You get points with that. So anyway, let's move on. We can go ahead and connect to this. We know that our notes, let's just take note of these down here. P given this, and, or that should have been Q given that, and P given that is just that. Wow, I suck at typing. So let's go ahead and just send line that. I'm not going to receive in here because there's a lot of data that we would have to deal with. Again, just going to go ahead and send information with this rather than receive, so we can do all the testing in our command line interaction. And I do want to know what that value is actually, so let's Python that. This. So we can keep track of these and go ahead and submit them as we move through the service. Yes. Oh, we need to actually tell it, yes, it is feasible. So sendLine string yes, and then fill it in. There's that. Okay, a new Madlib, we're going to need the following Q. That should be possible as well, because knowing this equation, n equals p times q, we can just go ahead and divide it. So s.sendLine, yes, that's totally plausible. And let's just keep a Python shell available to us that I'll just calculate answers in. We'll take n and divide that by p to determine our q. s.sendLine string, paste it in there with this math. Oh, I killed the connection. That's fine. That's why we're keeping track of these answers. And great. So let's do that again. Yes. Paste in the answers that we already have. Yes. Paste in the new answer that we have. Cool. Now we have E and N. That's just fine. Okay. Given E and given N, maybe we can factor this. Let's find out. Let's just bring it to factordb.com. Paste it in there. Looks like it is composite. It is prime. So, I'm sorry, it is not prime. So we can say no, that is not possible. And that's correct. So let's send that as well. Send line N. Great. Okay. Next one, we need to know the totient of N. Okay, so the totient of N is just P minus 1, that quantity, times Q minus 1, that quantity. And you can find that over here as you're reading more about RSA. So let's go ahead and determine that information. Let's do, because that only happens because these are prime, right? Oh, I should paste these in. Multiplied by this minus 1. We have an answer. s.sendLine, yes, because we know it is going to be feasible. And then s.sendLine string of that input. We'll keep track of the answer just as a comment, as we've been doing with everything else. And we'll just grab what we've tested with over here in our Python shell. Okay, yes, and then it wants to know that information. Oh, I totally failed. My bad. Okay, yes. Information that we already know. Wow, I keep hitting Control C or Control Shift C when I'm trying to work with my command line, not knowing that I'm not in my command line because I'm a fool. Let's turn this down as well. Hit it again. Okay, great. Now we have plain text, E and N, and now we're going to need the following ciphertext. Okay, we can totally calculate that as well, because we know all about encryption. It's C equals M, so plain text raised to E, the exponent, mod N, the modulus. So we can say that yes, that is possible. And let's do a POW function wrapped in string, right? Because we need to send strings. We'll use plain text M. Oh boy. Raised to E, which is 3. And then N being our modulus is the mod, the third argument to POW. Let's actually determine what that is, thanks to some handy dandy Python down here. And we have all of this, which I'm just going to paste in here so I can remove the L. And then let's go ahead and send it with yes and ciphertext. Great. Okay. Now we need the plain text decrypting from the ciphertext. Okay, that's not hard either. We know that decryption is just C raised to the D, which is M to the E, and we don't actually have D. Can we determine D when we factor N? Let's try and factor N with factordb again. Nope, we cannot. Okay, this is not feasible in our case, and that tells us, great, we can move on. s.sendLine, no. And now we have P and Q and E. We're going to need the following D. Okay, now that we know now that we know P and Q, we can in fact calculate D, because D is determined to be the totient of all those, right? The modular inverse. In fact, let's go ahead and grab that. We will need from crypto.util.number. That's built in, I believe. Maybe it's not. You might have to install like PyCrypto or Python cryptography or cryptography just with pip. And let's import inverse. So we're given Q. Let's just create variables for this. Looks like we are going to go ahead and time out. My bad. So P and Q are given. Now, to determine D, we actually need to figure out what that totient is, or what that phi variable is, and we did that just previously with q minus 1 times p minus 1, those quantities. And then the D is in fact the inverse of phi mod E, I'm sorry, raised to E, inverse. Actually, I don't know about that. Determine D is actually E. Okay, so it's E inverse mod the totient. I was using the wrong variable name anyway, I was using phi. So totient, just like filled out like that. So now that we've calculated D, we can s.sendLine. Yes, that is feasible. And let's actually print out D, maybe. I could just copy all this and put it in Python. Great. Now we have an answer. s.sendLine string of D. And we know that that is that, so which we can paste that in earlier or later. And let's go ahead and submit all of these just to move along. So we need to know N, copy and paste that. Yes, copy and paste this Q. No, we know that answer. The next one we know we do have an answer for. Oh, okay, great. Oh, we did not calculate this. Crap. Let's throw that in Python. Get an answer for that. Hit enter. Yes. Remove that L at the very end. Yes, that's feasible. Fill in the ciphertext. Great. Next, we're going to need the plain text. That is not possible, as we've determined. And then D is the final one, which we have determined is possible. And then let's paste it in here. Oh, we got it wrong. What? Did I have the wrong Q? Okay, how about P? Oh, I see the issue. I copy and pasted P. My bad. I didn't even copy the correct D. Fail. Oh, we need to import inverse in our Python shell that we're working with. So import from crypto util.number, import inverse. Now we can run that code. And D is not defined. Oh, because E is not defined. E should be this guy. Oh gosh, I pasted all of that. So E can equal that. That's the most common hex one that we end up working with. Okay, now let's copy and paste all this code, let Python run it, and now I have a D that I can actually submit, and should be the correct answer. Great. Let's try this again. Okay, I know this is a very painful video, I'm sorry. Yes, submit. Yes, submit. No, not feasible. Yes, submit. This one is yes, submit. Next one is not feasible, and now we need the D, which we can calculate, yes, and paste that in, and now we need to figure out the plain text, all this, given all this information. Okay, let's do that. We know we can actually do the full decryption of RSA because we're given N and P. Okay, we can figure out what Q is then. Given N, given P, now let's go ahead and figure out Q can equal N divided by P. Let's take E to be the variable that we know. Submit that. C being our ciphertext. C we can paste in. Did I add I did add a value there. And now we can figure out the exact same thing. D, based off the totient, because we know P and Q. And now we can decrypt it, where M can equal C raised to the power of D, all mod N, being the modulus. Okay, let's figure out what this is. Paste. Let's see what M is. We have this, which I will paste here and remove the L. Now let's say, yes, that is feasible. Let's submit it. And I did not remove the L. Gosh darn it. Let's send yes, and then let's send the string of M in our Python script. That should be the last one. That should be the last question, since we are like doing a full decryption of RSA there. So let's do s.receiveAll, and let's just print this out. Let's see if we can actually get the flag at the very end. So let's run Python ape, and yes, that is the last one. If you convert the last plain text to a hex number, then ASCII, you'll find what you're searching for. Okay, great. So let's print M dot. Actually, we want to convert it to hex first, right? So we don't need to receive any of this. Let's just roll through it. That's hex. Now, oh, I'm printing something else up here that I don't care to see. Okay, cool. Let's slice off the first two characters so that 0x gets removed, and there's no L to represent a long number at the very end, so we don't need to worry about that. Now we can decode it from hex, and we're given the flag. Awesome! Do you know the way to RSA? That is, again, the flag that we have already seen, just from ripping it from the top of the service, so kind of peculiar. At least I believe that is, yeah. Let's go ahead and find out one last time in Python. .decode hex. Yes, that is in fact the same flag. So it gives us the flag right away, just in hex. But if you want to roll through all those RSA Madlibs using the procedure that I had done, you certainly can. But hey, flag's a flag, whatever, right? If you wanted to, since all that service is really just giving you the RSA decryption stuff, you don't even need to communicate with the service once you have all that numbers. You can just make a get flag script where you just calculate that. But that's kind of handy to have this information if you want to just save it as a service. This can be our getFlag.py file, and we can mark that as executable. I believe we can do pwn.context level equals critical, and then that should, oh, okay, it's not removed. I'm always forgetting that syntax, but that context not right. Meh. Pwn.context.log level, that's what it is, I think. Pwn.context log level can be critical. Yeah, okay, cool. So that removes those opening connection and close connection information. So if you just want to run get flag, that should do it for you. Let's redirect that to flag.text. Let's save it to our clipboard so we can submit it. Let's move this challenge to be complete. And let's go ahead and submit it for some 250 points. I dig it. All right, cool, correct. Sweet. This challenge is called Be Quick or Be Dead 2. It's the sequel to the previous Be Quick or Be Dead challenge. It's worth 275 points in the reversing category, and it only has 537 solves. So that's not a lot, and this is now like mid-December, so it's been a while since Pico was actually finished, but a lot of people have still worked on it, but it's still not a lot compared to the surrounding challenges. So the challenge prompt here is as you enjoy this music even more, which is again another link to the Iron Maiden song. Another executable Be Quick or Be Dead 2 shows up. Can you run this fast enough? You can find the executable here on the shell server, but we're given the binary to go ahead and download. So let's go ahead and play with this. I will move over to my directory here. We can wget it, and this is actually the first time that I am like recording on my new computer. I just bought a Dell XPS 15, so hopefully this video won't suck, but I'll be fumbling around on the keyboard. When we try and run this binary, it gives us a banner, tells us it's calculating the key, and tells us you need a faster machine, bye-bye. So we can't do anything, right? We have no interaction with this binary. We don't know entirely what it's doing. Maybe if we wanted to, we could ltrace or strace some of this stuff. I don't know if that's, yeah, that's, okay. Printing out the banner, getting a SIG alarm, so the alarm handlers is occurring. Looks like it's trying to run that function after 3 seconds. So let's break this down, right? I'm going to open it up in Hopper, which if you don't have it, you can go to hopperapp.com and download a free version. I think the actual pro version or the licensed is only $90. I bought it and it's actually pretty nice. I don't have the license already set up on this machine just yet, but let's open it up and Control-Shift-O, not just O. where is the binary? There we go. Okay, so on the left-hand side, you can see all the procedures here, and I've got the main function locked on. And once we jump to it, we can hit Alt and Enter to view kind of a pseudocode decompilation, right? So looks like the main function will display the header, which if I click on here, will display be quick or be dead 2. Tries to show out those equal signs as a little horizontal line. That's nice. It sets the timer for us. Looks like it has a disclaimer if something goes wrong, but otherwise it will set an alarm for 3 seconds. And we see an alarm handler function over off to the left here, and that will simply say you need a faster machine, and it will exit. So looks like after those 3 seconds are up, we can't do anything. But if I go back to the main function, after that alarm handler is created and set, it moves on. So it tries to run get key, as you can see, right, because it told us calculating key, and then it calls this function calculate key. And then once it's completed, it will go ahead and spit out the flag. Looks like it uses decrypt flag as a function, so that key is probably very important. We will probably need to keep that intact if we are actually modifying or changing up this binary. So let's see how it does that. In the calculate key function, looks like it's calling this thing called fib, with an argument 0x422, so the hex number 422. If I click on fib, reading through this just even superficially, you can kind of assume this looks like the Fibonacci sequence, right? Recursive function with, if it's less than 1 or about 0, it'll return itself. Otherwise, keep calling it with variables being subtracted here. So this is the Fibonacci sequence. It is past 0x422. If we check out what that number is, and your number might be different, right? In my case, it's 1058. We need to get the 1058th number in the Fibonacci sequence. And that's going to take a lot of time to calculate. It's certainly not going to happen in less than 3 seconds. So we've got to try and figure out how we can modify or do something interesting with this binary and poke at it. So let's go ahead and do that. I want to showcase an interesting technique that I'm pretty pleased with. Although I cannot take the credit myself, a good friend of mine showed me this, but I think it's a very, very cool technique. So let's create a script for this user bin environment Python. Let's do from pwn import all. Going to be using pwn tools, and that's what I want to showcase here. The pwn tools documentation covers an interesting thing that you can do with binaries, right? If you have an elf object, or you've created kind of just a file or a binary that you're working with within pwn tools, you have a function that's really neat called ASM. And it will go ahead and assemble a specified instruction set, or the specified instructions, sorry, and insert them into the elf or the binary at the specified address being the first argument, assembly being the second. This modifies the binary in place. I'm assuming that's meant to say in place. The resulting binary can be saved with elf.save. So that means we can essentially modify, change up, and do cool things with the binary. We can patch the binary and patch the program without having to deal with it in Hopper or IDA or anything else that may be kind of clunky with the disassembler and GUI stuff, because I've tried to NOP or like no-op things out, or part of the procedure and processes within Hopper, and I would save a new executable and stuff like that, but it just would give me a seg fault, and it just wouldn't work. So I think this is a really cool procedure and process. So be quick or be dead 2. We've got the elf binary that we're working with here. Let's go ahead and run Python ape, and be quick or be dead. Gotcha. So the checksec banner runs. Looks like we have partial rel-row, no stack canaries, but an X is enabled, so no executing off the stack, and no position-independent code. That's fine. We don't care. We're not going to be dealing with that stuff in this video or with this binary or this challenge, but we want to actually take a look at what symbols we have, right? So if you wanted to, you can always check out the symbols that are actually present in a binary. You have elf.symbols as a dictionary. So let's do for key and address in elf.symbols iter items, we can print out key and then the hex of the address. And if you wanted to, you could literally always get an idea of where things are in your program. So you can look at the procedural linkage table. You can look at the global offset table. You can see some of the functions that it's trying to call or work with, right? You can see get key, you can see decrypt flag, etc., and where they're located in the binary. So we can take advantage of this, right? And we can also just go ahead and patch things with that elf.assembly file to essentially remove that alarm call. Let's say I wanted to have elf.asm So call this function with elf.symbols at the location of the alarm function, right? And let's say I don't want the alarm function to do anything else anymore. I want to make it useless, render it null and void. So what we can do is we can have the function go ahead and return. So simply do nothing. The instruction for that is just ret, right? And now that that's completed, we've essentially just said the alarm function is not going to do anything else anymore. After those 3 seconds, doesn't matter. We never even set up the alarm handler. Nothing's going to happen. So we'll go ahead and save this, right? We'll save it as a new binary, just like the documentation said. Now when we run the script, I have a new file, new, over here. And it's the same binary, but if we mark it as executable, go ahead and run it. It's going to try and calculate a key, and it's going to do this however long it takes, because we're not going to get that 3-second timeout. But we're still trying to calculate the 1000th and 58th, or whatever in your case, number in the Fibonacci sequence, right? And that's going to take a long time. Certainly way too long. So let's see if we can patch this binary to also just have that number ready. Let's go ahead and see if we can figure out what that number is. Let's go ahead and Google, right? I've seen actually bigprimes.net, and that's where I actually ended up finding this earlier. Bigprimes.net, if you go there, has an interesting archive of really cool numbers, Mersenne primes, prime numbers, Fermats, etc., and the Fibonacci archive. So if you were to click on one of these, you can view, 1000th Fibonacci number or whatever, you can view the specific page and specific number for any number in the sequence. So I'm going to change the URL, bring me to 1058, and you can use whatever you need in your case. And I will try to copy and paste this with my mouse just tweaking out on me. Please. Yeah, whatever. I'll just create a new document and we'll cut it up. So this is the number. This is what we would have eventually calculated, right? Let's go ahead and create a variable for that. Let's just say number equals that. And let's try and patch the binary so the calculate key function no longer has to roll through all those Fibonacci sequences. It'll just spit out this number. We'll say calculate key will instead, we'll just simply put this value into EAX, right? And let's use %s because we're just going to have to submit it in there. And then new line ret, new line. So just instructions here. On one line, set EAX equal to our number. We're going to have to add that in as the format specifier, and then return. So all it will do is immediately return that number. We will have to format specify it with the percentage here, and we want that number in hex for one thing. We also need to make it just a 32-bit number, something that will fit in that register. So the way I'm going to do that is actually use the and sign or ampersand, logical and, to crank it down to 0x1234 1234. So all the way just that 32-bit here. So that will fit in the register. And now that that's calculated and done, cool, we've patched that function, and we can save that. Let's go ahead and run the script now. Python ape. Great. So now we still have our new binary here. Let's run it. And just like that, we've got the correct key in place, and it can go ahead and print the flag for us. If we wanted to, we could streamline this. Let's import OS, and then we can probably do os.system chmod plus x new or something. Then we can run new, right, with process / new, and that could be p dot receive all, ideally. We might have to wait for it to do things. Pull.true. Nope. Oh, the issue is I'm not printing out what I'm receiving. That would do it. Great. Okay, cool. So we can actually just get the last line here if we wanted to. Split that up. I think there's a new line at the very end, so we'll have to get the second index. Cool. And then let's say context.log level equals critical, so we don't get all of that nonsense at the very top here. Great. So that means we have a successful getFlag script. So we can chmod plus x that, run our getFlag script, redirect that to a flag.txt file, and we can go ahead and copy that as well if we wanted to. I don't think I have Xclip set up on this new computer. So let's move Be Quick or Be Dead 2 to complete, mark that challenge as complete, and let's go ahead and submit the flag. All right. This challenge is the in and out error for 275 points. Has a lot of solves, it's just in the general skills category, and I don't see this challenge as that hard. Maybe it's just, I don't know, something that I've got to learn about Linux, like all the while I've been using it, so it wasn't difficult, but whatever. The challenge prompt is, can you utilize or utlize standard in, standard out, and standard error to get the flag from this program. You can also find it at this location on the shell server, so let's go ahead and download it and play with it. I've got a terminal open here, so let's wget this file here, and we can mark it as executable because it is just a binary. When we run it, it says, hey there, if you want the flag, ask nicely for it. Please enter the phrase, please may I have the flag. Okay, that's fine. Enter that. Thank you for asking so nicely. Floating point exception, core dumped. Maybe this doesn't have the exact same functionality on my computer as it does on yours. I don't know. I think it's because it needs a fake flag to be able to read out and work with. So if I were to have like my own flag that's maybe the program could open up and use, then it could probably handle this. But otherwise, it gives me that floating point exception. Okay, so it looks like there's a lot of garbage coming out there. So let's use the real like binary that's on the shell server. So I just want to copy that location, and I will go ahead and SSH over there as soon as I get my touchpad to play nicely with me. So I will just SSH in, go ahead and enter the password for your account, and then change directory to that location. That already has a flag.txt in there that we can't read. We have to use the binary for. But I'm assuming that's what the issue was earlier. So if I run it now on the shell server with their flag, try and run the in and out error program, it says, please may I have the flag into standard input, and it gives us all that nonsense. So we can take advantage of this, right? It's not too hard to simply pipe in or echo some standard output into the standard input of another program. So let's do that. Let's just echo, please may I have the flag. And now that that's on standard input, we can pipe it, that vertical bar, the shift formation of the backslash right above your enter key, into the in and out error program. So now it will give us all that information. Took a little bit of time, and now it's a lot of garbage though, right? So we want to work through this and see what we're dealing with. So an inkling, or maybe a good guess or estimation, is that, well, if it's telling us to deal with the three standard streams, standard input being number 0, standard output being number 1, the file descriptor, and standard error being number 2, we can work with these while we're getting information out of a program, right? If I said I want standard error, so I would say just the number 2 following the program or the command that I'm trying to run, and we can redirect it with that greater than symbol or the waka waka to a different location. If we put it to dev null, which is just kind of a digital trash can on your Linux computer, or a bit bucket there, it will all go away and it won't be visible. So now we get only standard output visible to us. And we are gifted, thank goodness, what a miracle, with the lyrics to Rick Astley's Never Gonna Give You Up. So, no flag in this. Let's try our other option. Let's try standard output, and that's the file descriptor number 1. Redirect that to dev null. And now we get a lot of nonsense here, but clearly this is the flag. It says PicoCTF, piping is a thing, and then some hex identifier. So my flag will be just different than yours. Let's go ahead and submit this, right? We solved it. We got the flag. If we want to, we can take note of it and remove our fake flag or one that we use locally to test. But please do subscribe. I dig that. And we can mark that challenge as complete, right? Not too difficult. If you want to automate something to connect to the shell server and then run that command and do it all, you are more than welcome to, but I don't think it's necessary for this video. Just a simple, hey, pipe in some standard input, like redirect some standard error and or standard output in this case, and just read on standard error. Interesting thing. This challenge is called Artisinal Handcrafted HTTP 3. It has 300 points in the web exploitation category and has about 924 solves. So kind of in the middle, not in the same 2,000 range, but not in the low 500 range between some of the challenges surrounding it. So interesting challenge, right? The prompt here says, we found a hidden flag server hiding behind a proxy, but the proxy has some interesting ideas of what qualifies someone to make HTTP requests. Looks like you'll have to do this one by hand. Try connecting to this netcat session and use the proxy to send HTTP requests to flag.local. We also recover a username and password for you to use on the login page, real business user, and whatever that is. So let's go ahead and copy this, right? Let's just move into our terminal, see if we can get a simple connect.sh script going. Just paste in that one line to connect to it. Not entirely necessary, right? But good practice for what we're doing. And just crank that to chmod plus x, and then we can connect. It gives us a CAPTCHA each time. You could probably write something to just determine what figlet or toilet font that this is, and then automate that CAPTCHA, but you don't entirely have to. We're going to be doing this as kind of stated by hand, so we'll just copy and paste whatever we're doing with our payloads, or at least our input as we move forward. So simply 5 minus 5 is 0 in this case, and it says validation succeeded, commence HTTP. Okay, so no real prompt here, just kind of on a blank line. We're sitting pretty, but we do want to make some HTTP requests. The most common one we would expect is just get, right, all capital get, and then we need a location following it by space. So the / is just the root location, and maybe you or I or whatever individual doesn't entirely know the kind of proper, perfect syntax for HTTP. That's fine. At least we can get an inkling when it responds to us. If I hit enter here, it tells me HTTP /1.1. So it will want a version, and it will also want a missing host header. Okay, so let's try that again. Let's do the CAPTCHA here. 5 + 1 is 6. Get / and then HTTP /1.1 for version, and then it wants a host header. So headers would follow the verb following the HTTP request, and it just wants the host here. We can say host : to specify the value for this, flag.local, as was suggested in the challenge prompt. So 2 new lines here, and it gives us a response. It says, okay, 200 okay, success, powered by Express, probably the Node.js framework. It gives us some source code here, HTML. It says a real business internal flag server. We see a link to log in, and you have to log in before you can see today's flag. Okay, let's start to try and put this in some notes for us. We know we can get the root directory with this syntax, just getting the root / here, and then flag.local. Now let's do that exact same thing, except the location that we want is / login. So let's copy this, connect again, 5 times 9, oh, quick maths, 45. Enter here, and we get all of this output. That's not very visible, so I'll do that one more time. Okay, so now we have a login form. We see the post method here, and it's sending it to the login page. 2 variables that we're working with, the username and the password. Thankfully, we were already given that in the challenge prompt, so we can go ahead and make this post request as well. Now, this has a little more syntax to it than we're probably already used to. Get is very, very simple, right? But post can have a little bit more headers that come with it. When I was first solving this challenge, I figured, okay, let's actually look up the syntax for a post request in HTTP. So I saw this MDN, right? This page from Mozilla developers here, and they actually had a lot of the real formal headers that I need between the content type, the content length, etc. You can scroll down and see an example of the syntax. So you supply your variables at the very bottom, and you've probably seen that before in Burp Suite or whatever other pen testing stuff, or maybe you've done this before with web requests. But we do need the content type and content length. So if we were to write this out, we would actually end up submitting a post request to login, right, with our variables user equals, at least according to that output, the name of that variable is user and the name of the pass is pass. So we can take what we're given here with real business user and the pass, whatever this is, &pass equals that, and we will get the content type. According to Mozilla Firefox, should be application / x www form URL encoded. So application x www form URL encoded, and then the content length we can highlight in Sublime Text to see what this is, 38 characters. So let's say 38 here. Great. Now let's go ahead and copy this, bring it to our shell. 6 times 9. Oh boy, 63? No, that's 7. 54. Goodness gracious. All right. Found, returned, set cookie, real business token is equal to this, and then a path is set for us. So it looks like we did successfully log in. It would redirect us to the /. So now we have a cookie that we can actually use to authenticate. Let's go ahead and add that as a header, right? Cookie equals all this, and then let's do the get / host flag local, etc. Now we can reconnect. 3 times 6, 18. Submit. And there we go. Hello, real business employee. Today's flag is PicoCTF only use non-GMO transfer protocols. That's funny. Cool. So if we wanted to, we could make a get flag script with this. Perhaps save this in a file and redirect it to it, or do some cat here doc, whatever. Let's try that. Get some flexing with a here doc. Let's do bin bash, right? And we want to put this in CTF, YouTube, Pico, additional, or Artisinal, get flag.sh, cat, something until EOF, right? I'm trying to figure out this syntax. Yeah, EOF, right? That should echo all those new lines. So now if I mark that as executable with get flag, we can run that. Oh, what is that? Peculiar. Let's go to Google. Google will rescue us. Google cat here doc. I typed Google into Google. // EOF, and then there we go. Now let's pipe that into our netcat connection, or in our case, connect.sh, which should be fine to use. Run get flag. Oh, we need to do the validation. Never mind. Guess we can't go ahead and paste that in. Maybe if we wanted to put those together, you could use probably Pwn tools and Python to manually do the validation and then send that information and then carve out the flag, or just simply, deal with the fact that we have received the flag once, we can save it, submit it, and that is good enough for us in this case. So let's mark that as complete, save this flag. And we can go ahead and submit it for 300 points. Paste, and we're moving. Must be logged in. Lost connection. Cool. This challenge we're looking at is called Echo, with a couple extra E's. It has about 300 points in value in the binary exploitation category. And the challenge prompt here says, this program prints any input you give it. Can you leak the flag? Connect with this netcat service, and we're given the source code and the binary. So if we want to, we can just go ahead and create a simple netcat sh little connect script. Cool. Mark that as executable. And then if you wanted to, you can connect just like that. And it will tell us, time to learn about format strings. We'll evaluate any format string you give us with printf. See if you can get the flag. So if you wanted to, you can download the binary and the source code here. I'll just download the source code because it would be good to see what this is actually made of. And let's open it up in Sublime Text. Okay, so now we've got the main function that that sets up a buffer for us with standard output. We'll read in a buffer. We'll actually read in the flag, get the flag pointer, etc. And it looks like it will set the effective user ID so that way it'll be able to read the flag file on the actual shell server, because they're going to use that to only be able to access the file if you were to log in through this binary. So then it goes ahead and it goes ahead. Wow, I can't seem to say those words today. Creates the memory allocation for these variables here, the flag and the buffer. Opens up the flag file, puts it actually as part of the flag variable, and that's accessible on the stack, right? That is actually read, so the flag variable is something that we can access if we control the stack. And thankfully, we do, because of this format string bug and vulnerability. Printf is a vulnerable function, right? If you don't give any other arguments or any format specifiers following someone's input that you can control, right? So if you Google this, there's plenty of resources on this. Format string, vulnerability, and I think OWASP and Code Arcana, I think that's it, Code Arcana. might be the best explanation of it, or at least showcasing a hardcore bug, in which case you can write values on the stack or write values at any location in memory and eventually give yourself a shell. So it eventually, at the very, very core, right, the format string attack is based off of the format specifiers that the printf function would expect. So given it anything here, you can actually see on this chart and this table, and there are plenty of the references for this, but if you were to enter %p, whatever is displayed would be returned as kind of an external representation of a pointer, or %d for a number or a decimal, %x for hexadecimal, etc., and %x, or I'm sorry, %s for a string. So we won't always be able to see %x, or I'm sorry, %s really, because sometimes we can't represent that data that we're looking at as a string, and the binary might go ahead and segfault. Let's go ahead and try that. Let's actually just download the binary, or you can run on the shell server, whatever you are more comfortable with. I think the binary will be a little bit easier in our case. We will just download it and mark it as executable, so when we run it, we can work with it. Let's create a fake flag file, though, because it will need something to actually work with. So let's do please subscribe. Cool. Now we can run this. Let's say we wanted to get anything returned back at us. That's what printf will do. But if we were to use those format specifiers with no other arguments given in the source code, what it's going to do is it will leak up the stack, because it's not expecting any other arguments that would be formatted in the source code. It's just going to reach upward to something that's not there and keep reading back into memory. So if I were to use that %x, you can see, okay, I'm getting some numbers here. %p maybe? Right, 0x40. And I can do this as much as I would like, and you can do this to literally leak up the stack. So very, very cool, right? But we want to get %s, right? Or a string, because we know the flag is going to be read in as a string. But we want to get it at whatever location, because if we were to keep trying %s, etc., we're going to get a segmentation fault regardless at that very, very first one. So we want to kind of pinpoint what it is that we're looking at and how we're going to leak up the stack. Now, you can do this in a very cool way. Maybe the printf man page will show how you can get a specific number. Guess not. Probably some other notions might. I want to see if this page actually explains it a little bit. Nope. Okay. How about this? Just trying to showcase how you can do your research. You can learn a little bit about it, because yes, while you can print %s over and over again, or %x, you can also just say, I want a specific location on the stack, this many pieces in. So that's talking about writing with %n. Let's say code arcana. This is the article that I was mentioning earlier that just talks about how you can take advantage of this to fully write onto the stack, write in the memory, and then essentially get shell. So super cool. But what I wanted to showcase is how you can say, yeah, I want a specific position, maybe 10 characters in. So if you were to reach the 10th argument of printf, or whatever the case may be, you would use the % there. % before the number, and then a $sign following, or just preceding the format specifier that you actually want to use. So I could run this again, and we saw 848647 on the third %x. So if I were to say %3 $x, now will only be returned this. So awesome, we can take advantage of this now to leak out potentially all the strings. So let's write a loop, or write something that will actually do this for us. I'll create a Python script that will handle it, because we are going to be connecting to the remote server so we can actually get the flag. Let's do from pwn import everything, context.log level equals critical, so that way we don't get that annoying connected and connection ended stuff. So let's do remote host and port, and we'll say s can equal that for our service or our session, and we'll say host and port is equal to cat connect. Go ahead. Do I have xlib yet? I don't think I set it up. I did. Excellent. Heck yeah. So host will be that string here, and port will be the number following it. Now s.close, once you're connected to it, we'll do s.receive until that prompt here. let's print all that out. And now when we run python ape context.log level, my bad, a little fast on that. Okay, now we are all the way to the prompt, and we can keep sending it new things. So let's do s.sendLine %x print s.receive, and we get that. Okay, so we've got the response. Let's say if we wanted it to be %s, we can print this, but we get an error. So, okay, is that s.receive returning to us? We can say if timeout, or how about, let's set this as a variable right here. Let's say response is equal to this. If timeout in response, or how about dumped core is probably better. Then print segfault. So we know, okay, we're getting a segfault on this. But let's say we wanted the second string. Else we can print what we receive. Okay, now we're getting some interesting things. Let's loop this, right? Let's go ahead and keep repeatedly connecting, because who knows if we get a segfault or not. So we will want to continually increase our incrementer here. So let's just say string of I, and we'll do for I in range, how about 10? So 10 characters up the stack. We'll keep leaking and building those out. And let's see how we do. Segfault, etc. And we got PicoCTF, format strings are dangerous. So if we want to see what position that was, we can just print I. And let's actually do that before everything, because if I use a comma there, it won't give me a new line, but everything else will. So at the 8th position, PicoCTF will give us the flag. 8th position up on the stack, we'll get that information there. So if I were to do that with manually, right, connect, and I use %8 $S, we are leaked out the flag that we saw on the stack because of fgets, and they read it earlier. So that's it. That's awesome. That's how we can do it. Let's go ahead and just carve that out now. Let's do a simple get flag script. Echo this into connect. Oh, we'll probably want single quotes here so we don't get. Is it going to keep doing? Is it going to keep connecting over and over again? Because otherwise, I want just a head tech or grep pico. How about that? Yeah, it's going to keep connecting over and over again. So that's silly. We can have our Python shell do it if we wanted to. Just trying to set up a simple one-liner command that we could just go ahead and say, hey, get flag, and it will return it out for us. So once we receive until, let's send line 8. Now that we know that that is where the flag is, we don't need to print any of that. We just need to print the response. Python ape, and just like that. All right, let's go ahead and strip out all of that, all the new line characters that came from it, and then we have a simple get flag script. Let's move ape to getFlag.py, mark it as executable, run it, redirect it to flag.txt now that we've got the real flag, and we can go ahead and put that in our clipboard and submit it for all of those points. So I hope that was kind of cool. Hope that was kind of interesting. I think that's an interesting technique. Whenever you see a format string vulnerability, you may as well start climbing the stack and just ignoring the segfaults and just trying to see if there's any interesting strings you can read out. So in fact, if we wanted to, let's actually keep working with that. Well, now we don't have an ape script anymore, but let's just say ape.py again. And let's bring this up to like maybe 100 or whatever we want to go ahead and leak out. We can keep running this until we see interesting strings, like, who knows, the environment variables in the box that it's running, or anything else that you might find valuable on the system. So I think it's always a good idea to try and leak up the stack as much as you can whenever you're given a printf vulnerability. So yeah, see, now you can see we're leaking out the environment variables that are set for that shell. So very, very cool thing. Maybe some people will hide valuable information in that. So just things to know when you're looking at a format string vulnerability. This challenge is called Learn GDB. It's 300 points in the general skills category. Not that difficult, kind of a simple task here, but the challenge prompt is using a debugging tool will be extremely useful on your missions. Can you run this program in GDB and find the flag? So we can go ahead and download this if we'd like to. I've got it open in a command line here. Let's just wget into our current directory. It is simply a executable, right? So we can mark it as executable, chmod +x. So we add the executable bit, and then we can run it. So decrypting the flag into global variable flag underscore buff. Looks like it's just having some progress bar kind of thing in dots there. And okay, now that that's done, it's exiting the program. Okay, so our goal is to open this and work with it and run it inside of a debugger. So GDB, or the GNU debugger, is a option for us. I've been using GDB Peta, which is the Python exploit development assistance toolkit thing for GDB. If you want to roll with this, you totally can. It is not necessary for what we're doing and just simply how we solve this challenge, but super easy installation. If you're using Git, you can just clone the repository, grab the source file, and put it in your gdb.init or .gdb.init file. So that's all. It looks very cool, though. It looks very, very hacker and very leet. All right, so let's GDB with /run so we can open up the binary. It looks like it is reading symbols, like it's got some stuff, so when we actually examine at that flag underscore buff, we actually can see some of that information here. So let's just go ahead and run the program again. Now that we have opened it up, but we haven't set any specific like breakpoints or variables, but the benefit of a debugger is that we can set a breakpoint. So at a specific portion of the code or at a specific location or somewhere along the progression there, we can stop the program and examine things like the stack or the registers or any other variables, etc. So if we want to find out a location in the program for that to happen, we can disassemble it with disass. And that's so much fun to say. Let's disass main, so main being the main function of the program. It looks like it move something, perhaps a string here, onto standard out, or I guess I'm not even going to pretend to know what that's doing. It just runs puts with whatever string, decrypts flag with that function here, decrypt flag, and then later puts. So after it's decrypted the flag, that's probably when we want to pause the program and try and look for it in memory, as the program suggested. So that's happening at this location here, at that location in the program. So we can copy that. I'm using Control-Shift-C on my terminal. And let's say B to create a new breakpoint. I'm using a star or an asterisk to say I want it at this location here. And I'll just paste it in. Now that that's broken, we can hit run or R again to run the program. And after it has decrypted the flag, we'll get all of the nice output that GDB Peta kind of gives us. It gives us the stack, it gives us an idea of what the registers look like, etc. And you don't have to have that set up if you don't want. Again, that's just what I'm using in GDB Peta, but I think it looks good and gives us a little bit more visual as to what's happening where. So at this location, though, we have essentially ready to say finish reading the flag onto this global variable flag buff. So if you wanted to, you could like p flag buff, or to print that out or something, or you can use X to examine that at flag buff. And if you wanted to, you could look up all those GDB instructions, or really how to use GDB in a man page. And there's plenty of documentation or guides for it online. So very, very awesome debugger and great for what we're looking at, especially with arguments, breakpoints, local variables, etc., etc. But what we can do while we're examining something with that X, we can specify how we want to examine something. We can specify the format or how we're looking at it. So X to print position in memory, and in our case, that flag underscore buff is fine to be able to use for us and read it. Well, let's say we want to see it as a string, right? Or a text, some piece of like real data and something that we can read as a string and as text. So let's do X/S, just as we saw earlier, examining that flag buff. And there we go. We get PicoCTF. GDB is super useful with that specific hash for our account. So we can copy that, right? Exit out of it, turn off caps lock, and save this. And then we can go ahead and submit it for 300 points. Not a difficult challenge, kind of cool, but good to learn your way around GDB and certainly know it as a tool. This challenge is called Flaskcards. It's worth 350 points in the web exploitation category, and it is the first in a series of CTF challenges that are kind of my favorite, especially from this PicoCTF game, because I think this is a really cool, I guess, attack and technique on some kind of software and technology that I really like and really love, because this is Flask in Python. I've got a video series on some of it, although it's not that good, admittedly. It's nowhere near what it should be. It's nowhere near done, but I digress. The challenge prompt here says that we found this fishy website for flashcards that we think may be sending some secrets. Can you take a look? So let's open up this website in a new tab here for us as soon as it loads. Cool. All right, so looks like we are given a simple welcome page, home in the navigation, and just register and log in. Wants us to log in, but we don't have an account yet, so I suppose we're going to have to register. Slow connections again. Don't know what that's doing for. So let's create a username. Please subscribe. Password can be anything. Oh, okay. Wow, that's rude. Please sub. Nope. Scribby. That's what I wanted. That's all my other testing accounts that I've been trying to do here. Please subscribe. Cool. All right. So now that we're logged in, the navigation has changed. We have home still nothing though. Just kind of the dashboard here. Admin page seems to not really do anything. Just tell us and say to us, you are not an admin. All right. Let's move on. Please subscribe. Nothing in the actual specific user account page. So let's go ahead and try and create a card. Looks like that is the only functionality that we have right here, and then we could probably list cards following that. So we're given a question. Okay. Will you please subscribe? Answer no. Because let's be realistic here, right? So check out list cards. Looks like that will be able to view them or everything that we've created. It says question, will you please subscribe? Answer, looks like there's nothing there. Okay, peculiar. If you wanted to, at this point, you could take a look at the hints, and if you don't entirely know what the reference and what this challenge is getting at with the name here, maybe that's a good idea. The hints say, are there any common vulnerabilities with the back end of the website? Is there anywhere that filtering doesn't get applied? The database gets reverted every 2 hours, so your session might end in explicit. Okay, whatever. That one doesn't matter. What we're going to be concerning ourselves with is the back end technology, right? And we can assume that, okay, this is Flask. This is Python, little micro framework for developing web applications. It's Flask in Python. And if you haven't seen this before, it's super cool. It's awesome. I love it a lot. Their latest version, like 1.0, is now a thing, and it's kind of more than what I'm used to because I was used to the like sub 1.0 version, and then I got a review. But, all right, Flask. We want to know if there are any vulnerabilities for this thing, though, right? So let's just simply Google Flask vulnerabilities. First article or first result is injecting Flask in an Invisium blog post. So let's open that up. It says, we're going to discuss some of the security features available and potential issues with Flask with respect to server-side template injection. Okay, cross-site scripting and HTML applications, subset of XSS, HTML attributes, sorry. The Discord notification popped up, and then I was like, whoa, totally distracted. All right, got that removed. So let's talk about injection, right? Let's talk about the server-side template injection, because that's a big vulnerability. For presentation, Flask takes advantage of the Jinja 2 engine and that templating engine. If you haven't seen it before, again, really neat thing. Uses some logic stuff with curly braces and percent signs, or just displays variables with 2 curly braces. Again, beginning and ending. So we can take advantage of that if we are in a vulnerable system or vulnerable service, right? And they go through some examples here with a little bit confusing code from what it really needs to be, I think. But what they're trying to do is render a template as a string, and that string is using some input or a variable that's being formatted into it that isn't particularly being sanitized. So normally you would simply use render template, and that's kind of a smarter way to give it an HTML file or something. But if you use it simply a render template string and then have unsanitized input into it, then maybe we can take advantage of stuff. So it looks like they're actually trying it out with a variable here, person.secret. Looks like they're trying to do some local file inclusion with a getUserFile function call. We don't know any of these variables, though. We don't know if it's maybe a card or cards thing. So maybe there are some other kind of globals or kind of configuration variables that we could be able to take advantage of. Let's say SSTI to kind of narrow our scope, or server-side template injection. Okay, so PortSwigger has a cool a very, very interesting article on this that actually should cover the actual vulnerability that we're going to see here. But again, we could test this, right, if we tried our own multiplication here. Let's try and use the example payload that they're using, which is trying to multiply numbers. If I were to create a card with the question 7 times 7, all inside those curly braces here, and I'll post that as an answer, we can list cards, and that should be evaluated now to 49. Okay. Great. So it looks like we have proved and we've taken advantage of that SSTI or server-side template injection. We know that that's happening. Now, what can we leak out of here? What interesting things can we do? Well, we can get variables, right? I want to see if they actually showcase what we're going to go for in this. And it doesn't look like there's a quick and easy pointer to it. So that's fine. We'll just change our query and search again. So Flask SSTI cheat sheet. Okay, cool. Looks like this covers a little bit in regards to the Tokyo Western CTF. Explains just kind of the bare bones basics of this vulnerability and exploit. Again, just abusing Jinja, the templating engine, and Flask, taking advantage of how it would render variables and trying to determine whether or not we will actually see inputs or see our input as evaluated Python code. So you can actually take advantage of this in a much more dangerous way, taking advantage of the MRO and looking at other objects in Python, and we'll do that in one of the later challenges. But for this one, it's actually pretty simple. All we need to take a look at are the context and global variables, like I was referring to earlier, just checking out configuration stuff, the current request object, session object, etc. So config should be what we're looking for. If we actually take advantage of that, that is just a global or something you can work with in Flask. And that actually keeps track of your secret key, which is a variable that should be kept secret, right? Or really kind of protected, because that's how cookies are going to be generated, or sessions are going to be protected. So that secret key is very, very important to safeguard. But we can leak it out, right? Now that we're actually seeing that entire config object, all of those variables and properties are being returned back at us. And if you kind of look through this, you can see, oh, hey, there's the secret key, and it's set to PicoCTF secret keys to the kingdom and a specific hash for our user account. So that's that. That is how we can go ahead and get the flag in this, and it's taking advantage of this Flask server-side template injection vulnerability. So very, very cool. Hope you guys enjoyed this one. I think honestly that's one of my favorite things. And whenever you see a Flask application as part of the CTF challenge, that should be one of the first things you should go to. One of the first things you should try is just those curly braces, see if you can get some math working, see if you can leak out the config variables or anything else that might be privy to that application.
Hey, me again. Just wanted to extend another huge thank you for watching my PicoCTF video tutorial series. If you like this kind of content and want to see more, please check me out on YouTube at youtube.com/JohnHammond010. Hope to see you there.